Hello, everyone, and welcome again to Black Box QA. So, in this video, we will see about why we are chosen Python as a scripting language, which we will be seeing in our further videos while we will be working with Selenium and APM. So, for that, why we have chosen Python as a scripting language. Okay, so this entire video would be very short and precise, and we will be knowing about the various benefits of using Python. So let's get started. Python's simplicity and readability, its huge community support, Python's rich libraries and ecosystem, and by using Python, development becomes faster, and so the execution. And it is very easy to integrate Python with Selenium and APM. And at the end, we'll be concluding this video. Okay, so let's get started. Uh, so we know that there are n number of scripting languages which can be used with Selenium and APM automation. But why are we going with Python here in this course? Okay, so Python has many advantages over other scripting language. Okay, so one such example is its simplicity and readability. Okay, so if so while working you'll get to know that Python syntax is very close to English, right, which makes it easy to learn even if a person is not from a programming background. So that's the beauty of it. Let's say you haven't had any kind of exposure before for any kind of a scripting language, but once you start with Python, right, most probably you won't be facing any kind of challenges as the syntax for Python is very simple. It's very close to English. Okay. So, and also Python syntax is designed to be intuitive and straightforward, allowing testers to focus on writing effective tests rather than getting bogged down by complex syntaxes. Okay. So before that, I wanted to show you with that. Uh, if you can see that there are two code snippets over here. So one is for Python, the other one is for Java. So by seeing through the number of lines of codes, for both Python and Java, you'll get to know that Python has less number of lines of codes, while Java has little bit more as compared to Python. Now, if you look one by one each line, comparing both these code snippets, you will see that it in Python you just need to import WebDriver. Though in Java you have to import WebDriver as well as Chrome driver. We'll get into more details on all these technicalities in further videos, but for time being, I'll just go through all of this one by one, and let me know if you face any kind of difficulties in the comment section in understanding this particular code snippet. Okay, so first of all, in order to automate uh, browsers using APM or Selenium, you first need to have its driver, right? So here we are trying to call the Chrome browser, okay, and Chrome browser driver. And here as well, we are creating a driver session for the Chrome driver, right? Now, to launch any kind of URL in Chrome driver, this line, this syntax is same for both Java and Python. And once you launch this particular URL, so this driver.get and whatever parameter you are passing over here, so that's the URL which will get launched into the Chrome browser. And once it's launched, here in the next line we are printing its title. So there is a title associated to each of the web pages, as you all might be knowing. So we are trying to print that title using Python over here, and we are trying to do the same thing using Java. So here it says system.out.println driver.get title. But here it's very simple. It's simply using print function, and then it's printing the title of the web page, and at the end it's quitting. So here you might be getting a very This is very simple code snippet, and you all might be getting a gist of it, that if we go further into doing all the scripting using Python, it's gonna be very simple, as the syntax of the Python is very simple and it's very readable as well. Okay. Okay, now going back to other features of Python as a scripting language. So yeah, we just saw the comparison of Python with Java, and this also describes the same thing. Like, it's easy to learn, readable, and beginner friendly. So Python's clear syntax and structure make it accessible for beginners, enabling new testers to quickly grasp automation concepts and start contributing to projects. Now, when it comes to performance, so Python has the excellent performance in automation scripting because of its efficiency in executing scripts, allows for rapid test execution, making it ideal for continuous integration and delivery environments. Okay, and yeah, so it's being adopted by developers, like it's been massively adopted by developers across the industries. And with a large and growing community, Python is widely adopted across various industries, various, I would say, ensuring a wealth of resources and support for automation testing. Okay, now Python's huge community support. So what does this community means? So before this chat gpt came into picture, initially, we as an automation tester or developer, uh, we used to, if we get stuck at any place using any scripting language, so we used to reach out to uh, the forums where people from across the globe, they are, putting all their queries, and the respective persons or team from the respective language, they use to address all those queries. So that's what we call as community support. It can be at the Stack Overflow, it can be at all the GitHub communities. So with that said, Python has a huge community support. So let's say there are over 10 million developers actively using Python, and the community is a rich resource of knowledge sharing and collaboration in automation testing. Okay, so tons of tutorials, Stack Overflow answers, and GitHub projects are there. So if you are stuck, chances are the solution is already out there, right? So this is one of the major benefit of using Python in any kind of automation project. Means solutions are all solutions most probably would be there. Okay. Now coming up to the next feature of Python, it has rich libraries and ecosystem. So for Selenium and APM automation, so Python offers Pytest. So it's kind of an IDE, just like an Eclipse if you might have used while working with Java. So Python offers Pytest for easy test framework setup. Okay, and it has unit test, like built-in testing support, requests for API testing integration, pandas and OpenPyXL for handling Excel test data, and Allure for reporting. Okay, so apart from that, it has NumPy for integration testing. So all all in all, if you see, like whatever kind of testing you're using, either it's UI testing using Selenium APM, or it's an API testing, or it's a mobile or web application testing. So it has Python has rich libraries and ecosystem. So uh, you name it and Python have it, kind of a solution is there. Okay, and last one is it has faster development and execution. So it works seamlessly on Windows, Mac OS and Linux. Okay, so and also the other features are like less boilerplate code, faster scripts. So Python's concise syntax allows for elimination of unnecessary boilerplate code, resulting in faster script execution and development. Okay, rapid prototyping with dynamic typing. So Python's dynamic typing facilitates quick prototyping, enabling testers to iterate rapidly and adapt to changing requirements. Okay, and also this makes Python a one-stop solution for tester who wants to broaden their skills. Okay, and now in this entire series we have focused on Selenium and APM along with Python as a scripting language. So it provides easy integration with Selenium and APM. Okay, so official support for Python bindings in both Selenium and APM. It's very active. Updates from the Selenium APM community and tons of boilerplates, projects, and templates available online to start quickly. Okay, so I would say Python is not just a tool for automation; it's the fastest gateway for testers to enter automation world, and it makes Selenium and APM testing simpler, faster, and more powerful. So, as this course will proceed, and we will be doing some hands-on experiences also, so then you will get to know like how simple it is to use Python in your automation framework. So the reason behind choosing Python was this only, like let's say if a person who do not have any kind of programming language and if they start with Python, I'm pretty sure they won't be facing any major challenges. Okay, so with that said, I'll conclude this video and hope you are all excited to get through the other technical videos which will be having soon. So stay tuned and happy coding. Thanks so much. Everyone, and welcome back to Blackbox QA again. So in this video we will be checking all the steps for setting up Python installation on Windows. Okay, so we have already seen why we have selected Python over other scripting language in the previous video. So in this video let's get started about installing Python on our Windows machine. So, in this section, we will deep dive into the essential steps for setting up Python on a Windows operating system. Okay. And as Python has emerged as a leading programming language due to its simplicity and versatility, making it a preferred choice for a wide range of applications. So, this we have already discussed in our previous video. So, we will begin with a comprehensive overview of Python and its significance in the programming landscape. Following that, I will guide you through the step by step installation, ensuring that you can also successfully install Python on your Windows machine. Okay. So next we will explore how to set up PyCharm. So if you guys haven't heard of PyCharm, so it's a IDE, basically an integrated development environment that will enhance the coding experience with its rich feature. All those features we will be exploring it while we will be doing hands-on with Python. And additionally, we will discuss the importance of creating a virtual environment to manage product or project dependencies effectively. So this is an important part, and you will get to know once we'll reach till there. Okay, and furthermore, we will be covering pip. So pip is the package management tool that will simplify the installation of libraries. Okay, so there are various libraries which we're gonna be using while working with Python. So pip will help us installing those, and we will conclude with the best practices for setting up a project requirement to ensure a smooth development process. So let's get started. Okay. So before that, to verify if Python is installed in your system or not, so for that we need to open the command prompt window. Yeah. So over here, we will be typing one statement called as python space hyphen hyphen version. Okay, so now this says Python is not recognized as an internal or external command. That means Python is not installed in a system. So I will guide you with all the steps, and if you want, you guys can also go ahead and follow all the steps parallelly in your respective machines. Okay, now let's open Chrome browser and let's go to our website, which is https colon double slash www.python.org slash downloads slash windows. Okay, so this is the official website of Python from where you can go ahead and download the latest version. So this is the latest version which has been released on December 5th, 2025. You can also check for the pre-release version as well. Okay, so you can find all of the versions which has been released earlier along with its downloadable link for Windows installer. But we will not be going with the latest version as it's just been launched and it could be not that much stable. So let's go ahead and you know download for any 3.11 version. So this is 3.13. Okay, this is all our 3.13. Keep scrolling down. Yeah, so here we have all those downloadable Windows installer link for 3.11.8. Okay, and it's been released on February 6, 2024 and cannot be used on Windows 7 or earlier. So uh, the system which I'm working upon has Windows 11, so this will work properly over there. So let's click on this link, 64-bit Windows installer, and our download has begun. Okay, so yeah, that was quick, and let's open up this folder. Yeah, so this Windows has popped up. So this is the Windows installer for Python 3.11.8, 64-bit. Now this has already clicked on this checkbox which says use admin privileges when installing py.exe, and the second one says add python.exe to path. So if you guys have worked with any other languages, for example Java, so you might have seen that after installing Java you need to set its path in the environment variable. So that you can do automatically from here after clicking on this checkbox, so you don't have to go and manually update those path in your environment variables. Okay, so once that is done, you just uh, you can go through this path as well, that your Python will be stored at this particular location, and once everything feels good you can click on install now, and here you can see the setup progress. Yes, so the setup was successful, and we can close this pop-up for now. And now let's go back to our command prompt window and see this time if our Python has been installed or not. For that, you need to open a fresh instance of a command prompt. Okay, let's do that. Type that same command, Python hyphen hyphen version. Yes, so this time we are getting Python along with its version which has been installed in our system. And also let's check if our environment variables also has the necessary inputs. So let's go to our environment variables. In here, as you can see, that this path contains our Python, where our Python has been stored. So this has that path over here, along with other necessary details. So that means that our environment variables has also been updated. So we are good on that part as well. Okay. Now, next part is to install PyCharm as an ID, which can be used as an ID. So let's open our Google Chrome browser again. Okay. Now, in order to install PyCharm, we have to navigate to this particular website, which is www.jetbrains.com, PyCharm download. So in here, you'll find a downloadable link for installing pycharm.exe file, and further installation steps you'll get to know soon. So let's wait for this website to get to get loaded properly. And now, initially, there used to be two versions. One was PyCharm Community, which was a free version. The other one was PyCharm Professional. Now, they says that PyCharm is now one unified product. So all users will now automatically start with a free 1 month pro trial version, and after that, they can subscribe to Pro, or if they want, they can keep using the core features for free, and now with Jupyter support included. So all in all, basically, it has now only one downloadable .exe link, and not like initially it used to have community and professional separate. So let's click on this .exe link. Now this should start our download. Yeah, here you go. So our download has been started, so it might take a while, so let's wait until then. Our download has been done, so let's navigate to this folder where our .exe file is placed. So it will be there under your downloads folder by default. Once you locate it, just right click on it, and it will give you an option to run as administrator. Select this option. This wizard has been popped up, so it says like welcome to PyCharm setup. All you have to do is just keep clicking on next until you reach the final step. Okay, so in here you need to select all these checkboxes. So what it will do, it will create a desktop shortcut, and update context menu means add open folder as project. You can select this as yes, or you can check this checkbox. Create association .py, you can select this checkbox as yes, and add bin folder to the path. So here, after clicking on this checkbox, there will be a restart which will be required to update the path variable, or basically those environment variables which we have seen earlier. So select this as this also, make it as checked, and once doing that, click on next, and do the installation. So for that, you need to click on this install, and this will take some time for this complete installation to be done. So let's wait for a while till this is completed. Okay. So our PyCharm installation has been done. So there are like couple of final mandatory steps are left, which we will do. So it says run PyCharm. If we select this checkbox, so after doing the finish, it will launch the PyCharm instance automatically. So as we can see, PyCharm has been launched. PyCharm IDE has been launched, and so basically, the look and feel of PyCharm IDE is more or less the same as we have see. So you guys, if you have worked with ID such as Eclipse or IntelliJ, so you might be seeing the similar UI over here as well. So in all the IDs, we'll see the files and folders being placed at the leftmost section of the screen. However, this screen is there for doing all kinds of coding and scripting. So here you'll see all the new tutorials, like what's new in PyCharm 2020, and also you will see all the other options. Like for example, if you have an existing Python project in your local, you can go ahead and click on this option to open it and have it installed or imported in your PyCharm IDE. So see, this has opened up your directory. And also, if you want, you can go ahead and create a new project from this option. So once you do that, there will be this new project getting created for you, which has certain instructions, or you can say some helping text, which will get you started with your scripting part. Now, let's say if you have a project which is being hosted in a remote repository, so you can clone it in your PyCharm by this option. You just need to put your repository URL over here, and you can download and install that project from the remote repository. Okay, so they have given the GitHub extensions also. You can log in via your GitHub credentials, and you can clone that project from the GitHub repository as well. So more or less, if you have worked with any kind of ID, PyCharm won't be troubling you that much. So for now, this was the entire step-by-step process to install PyCharm in your system. Okay, so before proceeding further with our coding practices in the installed PyCharm, I would like to draw your attention towards one more very important term called as the Python interpreter. Okay, so let's understand its role and functionality real quick before proceeding to the hands-on experience with Python and PyCharm. Okay, so Python interpreter is a fundamental component of the Python programming ecosystem, acting as the intermediary that allows developer to write code in a high level human readable format. Okay, so it executes Python code by translating it into bytecode, which is then processed by the Python virtual machine, right? So there are several types of interpreter, each with its own strength, such as CPython, which is the most widely used, and PyPy, PyPy, and also which enhances performance through just-in-time compilation. Now, the interpreter is utilized across various domains, including web development and data science, due to its flexibility and the rich ecosystem of libraries available. However, it is essential to recognize both the advantages, such as rapid prototyping and ease of debugging, and the limitations, including slower execution speed compared to compiled languages, when choosing to use the Python interpreter for a project. So, this is just basically a high level definition of Python interpreter. Now, uh, let me make it a little bit easy. So, now as we have Python and PyCharm installed, so we can start running our Python programs. But you know, for any computer that runs a program, like how the backend thing works. So first of all, uh, you might have heard about a term called as processor. So now with processor, there are two basic components. One is the CPU and the other is the computer memory. Okay. So the processor executes code is stored in a memory in the form of instruction machine code, and the result is stored back in the memory. So when we write a source code, the language needs to be translated into machine code for platforms such as, let's say, if you are using Mac, Linux, or Windows. So that needs to be translated into the machine code for the specific platform to understand. Okay. The translator used here is called compiler. Now, however, in Python, the flow is different. Now, when we write a source code in Python and execute the program, the Python interpreter comes into the picture. Again, now Python interpreter has two components. One, the Python virtual machine, and the second one is the compiler. Okay. So when we execute the source code, now pay attention to this part. Okay. So when we execute the source code, the compiler will convert the source code into a byte code instead of machine code. Okay. So with the concept of byte code being used in Python, this makes it platform independent. Okay. So the Python virtual machine will read and execute the bytecode on the hardware. Therefore, Python is both compiled and interpreted language. So yeah, before proceeding with any kind of hands-on activity, so I thought of drawing your attention towards what Python interpreter is. Okay, so now as we have all the prerequisites installed in our system, so let us run the first Python code, and we can run Python code in one of the three ways which I'll be discussing one by one. Okay, so first is using an interactive interpreter. So for that, you need to open your new command prompt window. And in order to start the Python interpreter, you just simply need to write Python and press enter. So with this, if you are getting this particular text, that means your Python interpreter has been started. Okay. Now let's do a simple print statement. So as we have seen in our first video, that in order to print anything, Python uses this print function. And let's type whatever we want to print. Let's say we are printing hello Python. And if we press enter, so hello Python has been printed. Now there are other ways as well. If you want to do some other hands-on practices with other kind of operations, so let's take an example of doing of printing name. So you just create a variable called as name is equals to hello world. Now as this is a string, this will be in double quotes, and if you print this, hello world has been printed out. Okay, so now let's do some other operation. Now here we are trying to print numbers starting from 0 till the range of 3. That means we are trying to print 0, 1, and 2. So for that we will be using a for loop for I in range 3. Also, you can take a look at the Python syntax. So this is more or less very close to the English language. So by reading this statement itself, we'll get to know that we are trying to print numbers, and we have assigned a variable as I in the range 3. Okay, so uh, now we will try and print I. Okay, so it has printed from 0, 1, and 2. Now let's say if you want to increase the range to 10, then what should be the output? Let's figure it out. Yeah. So it has printed the number starting from 0 till 9. Okay. All 10 numbers have been printed over here. Other than that, we can also, let's say, do some other operation. Let's say we define a variable called as name, and we assign a value as black box QA. And if we type name and then press enter, then it has printed black box QA. Okay. So there are other operations also that can be performed. Let's say if you want to add any two numbers. So for example, let's say we define a variable called as a equals to, let's give its value as 10. Let's define another variable as b and assign its value as 20. And in the third step, we are simply doing a plus b. So if we hit enter, we got the output as 30, which is 10 plus 20 equals to 30. Okay. So all these kinds of mathematical operation, string operation, we have seen how for loop also works, how print statement works. So this way we can use the Python interactive interpreter from the command line to execute our code. Now in order to exit this interpreter, you simply have to type exit, and this Python interpreter has been stopped. So this is one way. Okay. We'll discuss about other ways as well. So the second way is using the command line. So let's see how it can be done. So now let's see how we can run our Python code from command line. So till now we haven't reached till PyCharm. There's just various different ways in which a Python code can be executed. At the last, we'll go and see how we can run our Python code through PyCharm as well. But before that, let's see how we can do it through command line now. So for that, open a notepad. Okay. Now in this notepad, let's type in a statement for print. So we are trying in printing one statement which says hello from command line. Okay. Now what we'll do, we'll save this file, and let's give it a name as hello dot py. Now this py extension represents that, so py stands for Python, and now this has been saved as a Python file. Okay. So let's save it in our desktop. Okay. Now we will be so as our command prompt has already been opened, and we know that this particular file has been saved in our desktop. So let's change our directory to desktop where this file is saved, and inside desktop, okay, we will type this statement called as python hello dot py. So this is our file name, and if we hit enter, so it has printed that statement which we have given in our text file. Okay. So this is how you can run your Python code from the command line as well. Okay. Now let's discuss about PyCharm. So for that, let's open our PyCharm over here, and let's create a new file, new script. Let's delete all of this. Same way what we were doing with Python interactive interpreter using command line. Here also we can do that same thing, but this time we are using PyCharm as an ID. So let's start with our favorite print statement. So if we print hello, namaste, hola, and Kemcho. Okay. So if so, we have given a print statement, and if we want to print anything, let's run this file from here. So see, it has printed the statement again. So let's try and do a simple mathematical operation this time, and this time we will be dividing two numbers. Okay. So let's declare a variable a and assign its value as 10. Okay. Again declare a variable b and assign its value as 2. Now we have to perform division, a divided by b, and we have to save their output in a variable. So let's define that variable as result is equals to a divided by b. Okay. Now at the end, what we'll be doing, we will be printing that result. So you see the beauty of this pie charm. So it has already suggested like what could be the next step. We are trying to print the result before even we started typing it. Okay. So we'll just do a print. So using a tab key, if you feel like this whatever has been suggested will be your next step, you can press tab key, and then this statement will get appeared automatically. Okay. So if we hit, but before that, let's see why these red lines are coming. Okay. Unexpected indent, right? So you have to be very careful about the indentation. Indentation means the alignment should be very proper while writing the code in Python. Otherwise, it will keep throwing indentation errors. Okay, now this error has been gone because there was a space at the beginning of these two statements. Now our code looks good. And if we run this file, so see, we've got this print statement output as well as the result of 10 divided by 2, which is 5.0. Okay. So this way you can go ahead and do as many operations as you want. Let's say you want to print the name. For example, let's give this as my name is Python. Okay. And it has started giving you suggestions. So if you feel like you want to print the name, you just click on this tab key, and this will become visible. And this time, now let's run this file again. So it has given the output for all the three operations which we have performed. Now if you look closely here, we need not to need not to create any kind of main function where the actual operation will be performed. As we have seen in Java, that whatever variable you have declared its values and the operation which you want to perform on them, so that operation needs to be done under the main function, right? For that matter, if you have created or if you have declared those variables in a separate Java class, then using the object name and the dot operator, you have to call those variables from a different class to a class where the main function has been declared, because the actual computation will be done inside the main function only in case of Java. But here in Python, have you noticed that we haven't created any kind of main function as such? And how many operations you have to perform, you can do it in a single Python file. right? So this is the beauty of it. Means it's very simple to write the code, and it's very simple to, the code is also very readable, and the Python scripting does becomes very easy as compared to other scripting language. Okay, so now I want to draw your attention to one of the important topic while learning Python, which is called as name equals main. So if you haven't heard of these terms before, no problem. Soon you will get to know complete details about it. Okay, so this is our PyCharm. Okay, PyCharm ID. Now let's try and create a new Python file. We'll click on this new, and from here we can create a new Python file. Okay, so we have seen that Python provides these helping text. Okay, or you can say basically this is an executable code written in Python, which Python provides by default for our understanding purpose. So basically it's kind of an helping text. Now here you are seeing term called as name, and here we have this if statement which says name double equals main. And here what they are trying to do is they are creating one function called as python hyphen hi. Here they are giving name. Okay, and they are commenting and providing a text called as use a breakpoint in the code line below to debug your script. Okay, that's fine. Now we are trying to print hi and name. Okay, now in here this will be the actual part where your logic of the code has been written. So here they are using if statement. Now if name is equals to main, print hi pycharm. Okay, so let's try and run this. So it says hi pycharm. Now till now you will be thinking it's all very technical, but let me clear your concepts one by one. So basically in Python, every file is treated as a module. Okay, and every module has a built-in variable called as name. So this is the variable which is built in every module. Okay, now there are few important points about this name. So this name is automatically created by Python. You never define it manually, and its value depends on how the file is executed. Okay, so still you might be getting confused, but please stay for a while. At the end of like another 15-20 minutes, you will get to know about this name and main concept. Okay, so this name is Python's way of identifying how a file is being used. Okay, now uh, there could be like two scenarios, right? So for that, let me pull up my Word document. Okay, yeah. So let's consider two scenarios. First scenario one, where file runs directly. Okay, so in here, value of name variable would be main. Okay, now let's consider another scenario number two. Now let's say there's another file. Now we have to import that file. So consider there are two files, file A and B. We are importing file B inside file A and then executing file B. Okay, so the second scenario goes as file is imported. Then in that case, value of name would be module name. Okay. So for now, just keep this in mind, so that there can be two scenarios where file is running directly, and the second scenario we just discussed, two files A and B. B is imported inside A, and then B is executed. Okay. So what does all this scenario means, like, so this one variable main tells Python whether the file is the starting point or a supporting file. So let's say if you are running file directly, then that means this name variable will tell Python that this is the only file and this is the starting point from where you need to execute the code. Second scenario, where the file is getting imported into another file and then it's executing, there Python, so there this variable name will tell Python that this is a supporting file that needs to be executed. Okay. Now you guys might be thinking about, like, why does Python need all this? Okay. So you can think of this analogy, like, think of Python files like employees in a company. So there could be n number of files, right? Similarly, think of those files like those are the employees in a company. Now, some employees start the work. Okay. So basically, there could be teammates, right? So consider a team of seven people. Now, out of seven, let's say, uh, four or five people starts the work, so those will be declared as main. Okay. While the other employees are supporting it, so the other files in Python which are there, so those files are supporting the main work, basically, right? So technical reason behind this is, so Python executes all top level code in a file when it is imported, right? Now let's say there's a file, uh, or a utility file. Consider a scenario where you are creating an automation framework and you have created a utility file. Now that utility file has all these, you know, uh, you can say functions that can print logs, that can start a browser, and it connects to the DB also. So all these, you can say, functionality are provided in a single utility file. Now what you are trying to do is you are trying to import one of the function from this utility file. For example, let's say printing logs, right? Now what happens, okay, let me show you with a diagram. Just bear with me because this is gonna be interesting. So yeah, so consider this is the utility file. Okay. And inside this utility file, you can print logs. Okay. You can start a browser. Okay. And then you can have a function which connects to DB. Okay. Which connects to DB. Now the single utility file does all this operation. Now you want to import this utility file so that it performs uh, the operation of printing the logs. But let's say if you are not putting any kind of checks, then after importing this utility file, this will also perform like starting a browser and connecting to a DB. These two operations we don't want. We only want to print the logs as of now. So in order to have this check, right? Now let's say if Python did not have this check, right? Importing a file would accidentally run everything inside it. Correct. So in that case, this what we call as this whole setup is required in Python, right? Now again coming back to the technical reason. Okay. So Python executes all top level code in a file when it is imported. Let's say this utility file has been imported into some other file where we want to execute it or utilize these methods present in the utility file. Okay, so Python executes all those top level code. Now, without control, imports can, right? If you are not putting any kind of control, so imports can trigger unwanted execution, right? We don't want the browser to be launched. We don't want connection of the DB to be made. We only want to print the logs, right? So if we do not control it, then import can trigger unwanted execution. They can break the application and they can cause duplicate runs as well. Coming to the very last topic of this video, I would like to draw your attention about what is pip, virtual environments, and requirement.txt. Okay, so basically in this section, we will delve into the essential tools that every Python developer should be familiar with, which is pip, virtual environment, and net requirement.txt file. So pip serves as the backbone package management in Python, allowing developers to easily install and manage libraries, while virtual environment plays a crucial role in isolating project dependencies, which is crucial for maintaining clean and conflict free development environments. And last, the requirement.txt file is indispensable for ensuring reproducibility as it captures the exact dependencies needed for a project. Okay, and lastly, we will explore some common commands that facilitates the effective use of these tools, empowering developers to streamline their workflow and enhance collaboration, right? So at the very beginning we have seen like we have talked about a little bit about pip, which is the package management tool. Okay, so here let's deep dive into its further details. So for that, let me open my command prompt window. Okay, so here we have our command prompt window. Before we write real world Python projects, we must understand how Python manages libraries. So in this session, I'll explain three very important tools, which are pip, virtual environment, and requirements.txt. These concepts are used in every professional Python project, whether it's automation, web development, or data science. So let me start with a problem. Okay, so different projects needs different versions of the same library. For example, one project may require Selenium version 4.10 while another needs Selenium 4.18. So if we install everything globally on the system, one project can break the other. So this problem is called dependency conflicts, and Python solves it using virtual environments. Now, if I tell this whole thing in very simple words, so all these tools, what all they did, they does. So in very simple words, I can say pip installs libraries, virtual environment isolates them, and requirements.txt documents them. Okay, so let's start with our very first tool, which is called pip. Now, what is pip? So pip stands for Python Installer Package. It is Python's official package manager and is used to download and install libraries from PyPI, which is the Python package index. Now, whenever we want to use any external library like Selenium, requests, or Pytest, we use pip. So, if you have any idea about working with any kind of automation frameworks, using any kind of automation tool like Selenium, APM, right? So you might have seen that you are required to install certain other dependencies. For example, we have to install APM, we have to install Selenium, we have to install sometimes TestNG if you are going with a TestNG framework. Then if you are implementing BDD, then you need to install Cucumber libraries, right? So this pip does the same for Python. So pip comes automatically with Python and we use it from the command line or terminal. Now, if we have Python installed in our system, then you can be very sure that pip is also must be there installed in your system. So for Python, we have this command to check if Python is installed in our system or not. Same way, to check if pip is installed in your system or not, you have to write pip space hyphen hyphen version, and if you press enter, you will get this statement which says pip 24.0, and from where it is coming, that it will show the path of your local directory, and it is with Python 3.11. Okay, so Now, let's say if we install any package using pip, so let's go with request. Okay, so what will be the command for it? So you have to write pip, simply you have to write install and the package name, which is requests. Okay, so with this command you will be able to download or install the request package. Now, this package name will be different if you are trying to install any other package, but this command will be same, like pip install will be same. Just replace package, respective package with the respective package name. Okay, now if I hit enter, so this says this package has been already satisfied, it's already there in our system. And now let's say if we want to see the list of packages which we have with us, so for that you just need to run pip space list. This will give you a list of all the packages you have installed in your uh, project or in your system. So we have this request 2.32.5, right, which is already there. Now, let's say if you want to uninstall any package which you have installed, you don't want them anymore. So you can do that using pip uninstall. Again, you have to provide the name of the package which you need to uninstall. So once you do that, so it will ask if you want to proceed or not. So as we have to proceed, so click on yes or type y and then hit enter, and it will say successfully uninstalled request 2.32.5. Now, if you want to verify if we have it or not, then again you can run this command, which is pip list. This time, you won't be seeing any entry for request 2.32.5 as it's already been uninstalled. Okay, so this was all about pip. Now let's talk about what is virtual environment. Okay, so virtual environment is a self-contained directory that contains its own Python interpreter and its own installed packages. So this is the technical definition of virtual environment. Now, what does this mean? So this means every project can have its own Python setup without affecting other projects, right? So using a virtual environment is considered a best practice in Python industry. So we have just discussed about the scenario where you have a project which uses Selenium version 4.10 while the other package uses the Selenium version 4.18. Now, if you install Selenium 4.18 globally, then for the project where you need Selenium version 4.10, right? So that will create conflict and that will create chaos. So to resolve such issues, we have this concept of virtual environment. Okay. So let's do that using a live demo. So before that, let's try and create a blank Python project. Okay. So this is where our PyCharm projects are there. So let's create another project. Let's give its name demo Python. Okay. Now for that, we will open our PyCharm, and in here. Okay. So now let's import a new project, and here we will browse the project or the folder which we have created, its location, which was demo Python. So we'll select this, we'll select the folder, and we'll go ahead and click on create. Now let's do that in a new window. So we'll click on a new window. This will open another window of PyCharm, and it will prepare the project by installing various other dependencies. So we have installed this demo Python project in our PyCharm. Now let's talk about the virtual environment setup. Now, as you can see, it has this venv file, okay, and it has this main.py where we can go ahead and start writing our Python scripts. Okay, so before that, let's do one thing. Okay, so this is our path, right, for the demo Python. Let's copy this path and open a new command prompt window. Okay, Now in here, let's navigate to this particular path, and again let's go to demo Python. Okay, so we are inside the demo Python folder. Now, in order to create a venv file, okay, so there's this command called as Python space hyphen m, then venv space name of your venv file. So you can give any name. Let's give venv1 for now. Okay. So if we hit enter, so this will create a separate venv1 file in our Python project, which is there in our PyCharm. So I'll show you how it gets created. Let this get completed once. Okay. So now once it gets created, we have to activate this also. So for that, what you need to do is you need to write venv1, okay, then backslash scripts, then again backslash activate. Okay. So as you can see, you are now inside venv1, right? Let's see what's happening in our PyCharm ID. So initially there wasn't any such folder venv1, which has now been created. Okay. So inside this, if you go, so this is the lib package. Inside this, there's this site packages where you will see all the kinds of packages being installed. So just have a look at it. So it has pip 24.0, package resources, setup tools, all the various other ones which comes by default. Now let's try and install request package for this venv1. Okay. So if we go again to our command prompt window, we'll be using pip command to install request package. Once it gets installed successfully, as you can see, the process has started. So once it gets installed successfully, you will be able to see that request package coming under the site packages. Yeah, so it's been done. Now if we go back again to our PyCharm, so this time under venv, you will see this request coming up here, right? If you want to come out of this, you can do that using deactivate command. So once you do that, you have come out of this venv1 file. So now let's create another venv file inside that same folder, and this time let's give it name 2. Okay. So you can create as many virtual environment in the same Python folder, or you can say Python project. Okay. So this time we are creating another virtual environment with name as venv2. Yeah. So this is done. Now it's the time to activate this. So we'll type venv2 backslash scripts backslash activate. Now we are seeing venv2 over here. Let's find out what's happening in PyCharm. So initially we have this venv1 which we have created. Now this time there's another folder called as venv2. Inside this we have this lib folder again. Okay. And here we had this requests present. So now this time let's install the request package for venv2. Okay. Initially there's no such thing as request present. Or else let's do one thing, let's install any other module. So for that, let's install Selenium. Okay. And if we hit enter, it has started installing Selenium, right? And once it's done, you will see that respective Selenium packages will be there for venv2. Okay. So Selenium has been installed for venv2. Let's find out if it's there in our venv2 And inside it, if you look at the site packages, you will see Selenium 4.39 getting installed. As we haven't specified any kind of Selenium version, so it has taken 4.39.0 by default. But yeah, if you want any specific Selenium version to be installed, you can give its version name beside the Selenium. Okay. So this is one thing. Now, let's say if you want to uninstall these packages, right? So for that, you can use the pip uninstall command. So this will be like this: pip uninstall Selenium. And if you hit enter, it has again asked our consent to proceed or not. So let's give yes. So it says successfully uninstalled Selenium. If we go back to our PyCharm, this time you won't be seeing any Selenium related package or folder inside VENV2. So that's the thing. Now let's say if you want to jump from VENV2 to VENV1 again, so simply you have to deactivate this VENV2 to come out of this. And if you want to go back to VENV1 again, you have to use this VENV scripts activate, because if you want to go inside any kind of virtual environment, first you have to activate it. Okay. And we are again inside this VENV1. Now let's say we had install request under this VENV1. Okay, let's try and uninstall this as well. So again, we will be using pip uninstall requests. So it has asked to proceed or not, so we'll click yes. So as you can see, it has installed the request 2.32.5. Let's check in our PyCharm. And this is VENV and this is site packages. You won't see any package or folder related to request now. So yeah, that's the beauty of using Python. It's a best practice also to separate your dependencies based on your requirement into separate VNV. You can create virtual environment and you can install the various other dependencies which you require. And it's not ideal to install all those dependencies globally, because as we have already discussed, it will create conflicts. Okay. Now let's go to our final topic, which is the requirement.txt file. Okay, so as per the definition, a requirements.txt file is a simple text file that lists all the packages and their exact versions used in a project. Now, how does it help? So, it helps us to share projects with teammates, to recreate the same environment on another system, and to maintain consistency in production and CI CD pipelines. Okay, now first, I'll activate the virtual environment and install few packages. Okay, so let's we are already inside VENV1, so let's take that as our current virtual environment. And this time, let's install using pip. Let's install one package. Pip install Selenium again. Okay, this time in virtual environment one. Okay, so we have Selenium installed in our virtual environment one. Now I'll generate the requirements file. So for that, you have to use this pip command called as pip freeze, then open arrow requirements dot txt. Okay, so once you hit this command, so a requirement file will get created. Okay, now let's see in our PyCharm if it's been created or not. If we go there, so here we are seeing the requirement.txt file. Okay, now we have this requirement.txt file getting created. Okay, so this file contains the exact versions of installed packages. So if someone else clones this project, because anyways you will be creating this Python framework and you'll be pushing your code into a remote repository. So let's say if someone else clones the project, they can recreate the same environment by running this particular command. So pip install -r requirement .txt. So the thing is, having this requirement.txt file, uh, if anyone else clones this project into their local, they just need to run this command, and whatever uh, installed packages exact versions are mentioned in that file, so all of that will get installed into their respective system. So if we look at this requirement.txt file, right, so we have the Selenium 4.3, 4.39.0, which we installed in VE and V1. Along with that, there are other packages also. Let's say, along with Selenium, you install other packages as well. So once this whole project has been cloned into any other system having this requirement.txt file, they just need to run this particular command, and whatever package along with its version mentioned, they all will get installed into their respective system. Okay, so this command installs everything automatically, so they don't need to implicitly do pip install for their respective packages which they want to install. Just run this command once and everything will be done. Okay, so imagine you send your project to a teammate or deploy it on a server without requirement.txt file. Imagine. Okay. So you would have to manually install libraries just as we did before. I was showing you about this pip install commands and this virtual environment command. So we were installing it manually one by one. But let's say if you have this requirement.txt file and if it's been cloned to some other system, by running this particular command which we have just discussed, pip install space -r requirements.txt, all of the uh, packages will be installed automatically. And so with requirement.txt, the environment can be recreated in seconds. So that's why every professional Python project includes this file. Okay, so let's recap about it. So what we've learned, we've learned about pip install Python packages, virtual environments, isolate project dependencies, and requirements.txt records package version. So if you remember one rule, remember this: never install packages globally. Always use a virtual environment. So I'm repeating this again: never install packages globally. Always use a virtual environment. Reason being, it will create conflicts. And these concepts may look simple, but they form the foundation of real world Python project. So once you understand pip, virtual environments, and requirement.txt, you are thinking like a professional Python developer. Okay, so with this, I'll conclude this video. Here we have learned lots of things, starting from installing Python, then PyCharm ID, doing some kinds of hands-on with Python code, and then learning about what is name equals to main, what its significance, and also we have learned about pip, virtual environments, and requirement.txt files. So with that said, I'll be concluding this video, and if you like it, then please share it and subscribe it. Thank you. Hello and welcome again to Black Box QA. So, agenda for this video would be to understand the concepts behind variables and data types in Python. And in the second part of the video, we'll talk about the operators that has been used in Python. Okay. So, without further delay, let's start our video. So, in this section, we will delve into the foundational concepts of variables and data types, which are essential for any programming endeavor. A variable is essentially a named storage location in memory that can hold different values during the execution of a program. Okay, so understanding the various types of data, such as integers, floats, strings, and booleans, is vital, as each type has its own characteristics and use cases. Okay, so for instance, integers are used for whole numbers while floats are suitable for decimal values. The importance of data types cannot be overstated. They influence how data is stored and manipulated, which in turn affects the performance and efficiency of applications. Additionally, we will explore the distinction between mutable and immutable data types, which is crucial for understanding how data can be modified. And finally, we will look at examples of variables declarations across different programming languages, highlighting the syntax and best practices that enhances code readability and maintainability. Okay, so before we write any kind of automation scripts, frameworks, everything starts with data, right? To store data, we need variables. And to understand data, we need data types. So if I say your age is 27 and your name is John, so are these two same kind of data? Obviously, the answer will be no. So that's your entry to data types. Okay. Now, if I ask you what is variable, so a variable is a container to store data and it gives a name to a value, and value can change. So that's why it is called variable. So this whole thing is pretty much explanatory. So to store any kind of data, we need a container, and that container is called as variable, and we give name to a value, and so value can change. That's why it is called as variable. So let's consider a scenario where we are declaring a variable called as age and assigning its value as 25. Okay, so think of it as store 25 inside age box. Okay, so let's make it more clear with an example. Let me create another variable called as name and give its value as John. Okay, and another variable called as age and give its value as 27. Let's say John has a salary of 50,000 per month. So declare another variable called as salary and assign its value as 50,000. Okay. Now, if I want to print all of these value, we will use print function and we will give parameter as name, which is one of the variable name as well. In another line, let's print age. So we'll put the variable name as age, and at last let's print salary. So we will provide the variable name salary inside the parameter. If we run this section of code, okay, we know what would be the output. So let's run it. We will get the output as John 27 and 50,000. Here we have just provided the variable name, and the output which we are getting are its value. So did Python ask you what type of data it is? No, right? So Python is smart enough to understand. Python is dynamically typed. So you do not declare type in Python. Python automatically detects type it at runtime. Now let's take another example. Okay, so here we are declaring variable as x and defining its value as 10. And let's try and print this value. Now if we run this file again, we are getting the output as 10. And let's define another value for x, this time as hello. Okay, and in the next line let's print this value. Okay. Now if we run this file again, we are getting hello as printed. So that means we haven't declared any type in Python, and Python automatically detects type at runtime, right? Here we are declaring value of x as 10, which is an integer, and here we are declaring it as hello, which is a string. So, same variable name, different data, Python allows it. You might be using Java or other languages. So, this privilege was not there. You have to explicitly provide int or string. Then only those languages will get to know what type of data it is. But in Python, Python simply allows it. Okay. Now, next topic will be variable naming rules. So, there are certain rules which you need to follow while creating variable or defining a variable. So a variable must start with a letter or an underscore. It cannot start with number. There should not be any special characters, and it is case sensitive. Okay. So let's discuss this with an example again. Here we are declaring a variable called as first underscore name and assigning its value as, this time say, Rahul. Okay. Let's create another variable name. Now this time let's start with an underscore and give this variable name as age and assign its value as 25. And again let's create another variable called as pi and assign its value as 3.14. Okay, so we have uh, declared all these variables along with its values, which comply with all the naming convention rules which we've just discussed. And if we try and print these values, okay, let's try and print first underscore name, then let's try print age underscore age, and again let's try and print pi. And if we run this file, we got the respective output. Now if we go ahead and create a variable name which do not comply with any of the rules which we have just discussed, so let's create a variable name called as one name is equals to abc, and let's have this first dash name is equals to abc. And so see, it has started throwing the errors. It has highlighted this one over here, and it has highlighted a dash over here. Means it cannot start with a number. So here we have started with a number, and it has given the error, and it should not have any kind of special characters. So dash is treated as a special character, right? So this has already highlighted the error. So this is a bad naming convention practice. So that you have to keep in mind. Okay, let's proceed further and discuss about the Python data types. Now every value in Python has a type. Okay, and for example, let's talk about int and have, if we consider its value, then let's give this 10, so meaning a whole number. Okay, so whole number. So whatever whole numbers are there, those will be considered as int or integer. If we talk about float, so float will have decimal numbers. So example would be 10.5. Okay, so decimal numbers will be treated as float. If we talk about string, str, so example would be text written inside double quotes, which could be hello. So any kind of text which is written inside double quotes will be treated as string data type. And uh, let's talk about boolean. There's another data type in Python, so it will have this bool, and it will have the following two values, either true or false. Okay, so all the logical values will fall under boolean data types. Okay, and there's another data type called as none. So this is called as none type. And example would be, if we provide simple none, it will be treated as none data type, and meaning would be empty or no value. Okay, so we'll now demo each with practical example. Okay, so for now I'll just delete this also. Let me delete this because this is not a best practice. And let's give or declare a variable called as a and assign its value as 10. Let's declare a variable called as b and assign its value as -5, and variable c, and let's assign this value as 1 lakh. Okay, now if we try and print like this, print type of a. Again, in the next line, let's print type of b. And the third line, let's print type of C. So what could be the output? Okay. So if we try and run this file, we've got these results: class int, class int, class int. So this explains all of these values are of type int. Okay. Now again, let's discuss some variables around float data type and create a variable called as price and assign its value as 99.99. Again, let's create another variable and assign its value as 18.5. So we have created two variables, price and GST, and we have assigned their values, which are the decimal numbers. Now, if we try and print price, comma, GST, okay, and in the next line, if we print the type of price, so what would be the output? So let's try and run this file. Now for price and GST, we've got these values 99.99 and 18.5. However, for printing the type of price, so it has printed class as float because all the decimal number will be treated as float data type. So we can use float for money, measurements, and percentages. Okay. Again, let's discuss string as well, string data type. For that, let's create a variable called as name and assign its value as Python. And in the next line, let's create another variable called as city and assign its value as Pune. Okay. Now, if we try and print name dot upper, okay, and in the next line, let's try and print len city. What does this means? You'll soon get to know once we run this file. So if we run this file, let's see the output. So here we have written Python, which was having P as capital, rest everything was in small case. So with name.upper, we are converting all the rest of the characters which were in small case to capital. So here it has printed every character in capitals. And len means length of this particular value which we have given as Pune. So if we count the character, it has four characters. So len city means it will print the length of this value, which comes out to be 4. Okay. So for any kind of text, if you are dealing with any kind of text value, you can use string data types. It should be surrounded by single quotes or double quotes. So if, let's say, here I've given double quotes, let's say if I give single quotes also, then this can be treated as valid. Let's convert this to single quote and then run this file. Output would be same, right? Python and 4. And if further going deep into string data type, it has some very powerful functions. Couple of them we have seen just now. One is the upper and the second one was len. Okay. Okay. So again, let's discuss about boolean data type. Okay. So we have seen, if you are dealing with any kind of logical values, boolean data type would be the best fit. So for this, let's create a variable name called as is underscore active and assign its value as true. In the next line, create another variable called as is underscore admin and assign its value as false. And if we try and print the type of is underscore active, so what should be the output? Let's see. So it has given that this particular data type represents class bool. Okay. So along with all the logical values, this data type can be used in conditions, automation checks, and test assertions. So while we will be working with creating the automation frameworks, there we're gonna be using this particular data type bool a lot. Okay. So let's discuss this with another example. If we declare a variable name called as age and define its value as 18, okay, and if we try and print age greater than equals to 18, okay, now if we run this file, the output would become as true because age is 18, and here we are giving an expression where age should be greater than or equals to 18. So equals is coming, hence the output is true. Now if we remove equals to from here, the output would be false because here we are considering age as greater than 18, but that's not the case. So it has given the output as false. Okay. Now the last data type is none type. This is something which you haven't seen in any other language, but it's there in Python. So let's discuss this. So none type, okay? None means nothing, empty or no data. Simple, as the name suggests. Okay. So let's discuss this as well with a example. And here we are creating a variable name called as user and giving its value as none. Simple type as none. Okay. And if we print user, okay, and in the next line let's try and print its type. Now after running this file, so this has printed its value which is none, and this represents to the class as none type. Okay. So this was all about the various data types which we'll be dealing in Python. Okay. Now let's discuss another topic which is called as type conversion. And sometimes we need to convert data from one type to another. This you might have seen in while working with other languages as well. So type conversion, what it is, let's discuss this with an example. Okay. So here let's declare a variable a and give its value 10. Now this time 10 is surrounded by double quotes, and double quotes, whatever you are giving in double quotes, that will be treated as string, we have seen. And let's create another variable called as b, and here we are giving its value as 20. Now if we print simply a plus b, okay, so what should be its value? Okay, let's see. While running this file, see, it has given the error that here at print a plus b, type error, and can only concatenate string, not int to string, because this is treated as string as of now, and you cannot concatenate a string variable value to a integer one. So for that, you have to change the type of variable a. So for simple type conversion, you just whatever data type you want to change this particular value, you just put the name of that data type and surround it with small brackets. Okay, let's put a inside the small brackets, and this time if we run this file, we won't be getting any error, and we'll get the output as 30. So 20 plus 10 is 30. So this is called type conversion. Now let's take another example. What we will be doing here is we'll be creating a variable called as num and assigning its value as 100. And if we print this value num, but let's print this by doing a type conversion from integer to string. So for type conversion, we'll give the data type name and surround that particular variable with small brackets. Okay, and let's provide some text as well. Is a number. So if we run this file, so what it says, 100 is a number. Now if we do not do this type conversion, it will give the error, right? Because this particular section is a string, and if we do not do any type of type conversion, and if we run this, so you cannot concatenate an integer with a string, right? So it will throw the error, unsupported operand types for int and string. Now this is declared as int, right? So if we do this again, like if we convert this to string, then it will work fine, because a string can be concatenated with a string. The data type should be same as we have seen over here. Okay, now let's discuss another example. Okay, this would be an interesting one, so listen it very carefully. Let's declare a variable a and assign it a string value called as hello. Okay, and if we try to print by converting this string data type to int, so for that, let's provide the int data type and give this variable name, and yeah, that should be it. And yeah, now if we run this, what should be the output? So if we run this, see, it will give you an error where it will say invalid literal for int with base 10 hello. Okay, that means you can convert number strings but not text. So here in the above example, what we saw was a number string, and after converting it to int or the integer data type, this worked properly. But in here we have string text already, and then we are trying to convert it to the integer data type. So in that case, it's not possible, and it has given us the error. So you can convert number strings but not the text. So this is one such example which I wanted to show you. And So we have learned about all these data types, variables. So we can use this in Selenium automation for example, storing login data. Let's say if we are doing API testing, in that case, we can use it for handling responses. For database testing, we can use it for handling records. And let's say if you are performing any kind of data science activity using Python, so in that case, we can use it for working with numbers. Okay. So if we conclude and summarize this video, so what all we have learned about variables store data. We have seen Python auto detects type, and common types are the integer, float, string, bool, and none. Conversion is possible. Okay, so this is an important point where it says like conversion is possible, and it can also help you in building strong foundation for automation and real world programming. Now, if you master variable and data types, you control your program's data. And if you control data, you control the logic. Okay? So this was all about the data types and variables in Python. Now let's discuss about operators in Python. So in this section, we will be deep diving into the concepts of operators in Python. So which are fundamental to performing operations on data, right? Operators are not just symbols, they are the building blocks of expressions that allow us to manipulate, variable, and perform calculations. Okay, we will explore the various types of operators available in Python, including arithmetic, comparison, logical, bitwise, and assignment operators, each serving a unique purpose in programming. Through practical examples, we will illustrate how these operators are used in real world scenarios. Okay, and additionally, we will discuss the importance of operator precedence and associativity, which dictate the order of operators in complex expression. And finally, we will highlight common pitfalls that programmers encounters when using operators. So, if we talk about operators in Python, so basically operators are symbols that perform actions on data, just like we use plus, minus, multiplication in maths, right? Python uses operator to perform calculations, decisions, comparison, and automation logic. Now, let me ask you a question. Is 5 greater than 3? Everyone would be knowing its answer. So the thing is, can we check this using Python? Yes, we can do that. And this will be the basic building block of operators in Python. Okay. So let's discuss about arithmetic operators. So arithmetic operators are used to perform mathematical operations, and it includes various operators called as addition, subtraction, multiplication, division, modulus, power, and floor division. So let's open our PyCharm. Let's remove all of this. So if we talk about all these operators which we just discussed, so addition, basically what it does, it adds two numbers. So there are two operands required. Same way for other type of operators also, two operands are required. Now uh, let's see with a live demo. Okay. Now if we declare a variable called as a and assign its unit as 10, and declare another variable as b and assign its value as 3. Okay, now let's perform all these arithmetic operations. So we will do first addition. Okay, then let's do subtraction. Okay, now let's perform multiplication, division, which will be a slash b, and here for multiplication we are using asterisk symbol. Okay, And let's perform modulus operation, which will be a modulus b. Okay. Now let's perform the power operation. So for power operation, what we will be doing, we will be using double asterisks. Okay. And at last, let's perform floor division, which will be a double slash b. Okay. Now let's check their output first. Okay. Then we'll discuss about their functionalities. So if we run this file, yes, so we've got the output. So a plus b is simple. So 10 plus 3 is 13. A minus b, we are doing subtraction. So 10 minus 3 is 7. A multiplied by b, which is 10 into 3, which is 30. Now this one, a divided by b. So if we divide 10 by 3, we'll get a decimal value, because 10 is not completely divisible by 3. It's simple mathematics. So it will give 3.333 and so on. Now, when it comes to modulus, so modulus always gives the output of the remainder. So it's basically a simple division, and what we'll get is, like, let's say if we divide 10 by 3, so at the end we will get a remainder of 1, right? Yeah. Now let's discuss about this power operator, which is represented as double asterisk. So here, what we are trying to do is, we are trying to have 10 to the power of 3. Okay. So for 10 to the power of 3, right, if we perform it in using normal calculator, we will get 1000 as the output. And this floor division, if we divide, if we do floor division of a and b. Now let's discuss about this floor division. So for those who haven't heard about this floor division before, so floor division in Python is a special kind of division that divides two numbers and rounds the result down to the nearest whole number. Now, if we at this particular point where we are trying to divide 10 by 3, so we were getting this decimal value, which was 3.333 and so on. Now, in floor division, what it will do, it's also a kind of division only, but whatever result we will be getting, it gets rounded off to the nearest whole number. Now, the nearest whole number for 3.33 is 3. Hence, the output is displayed as 3. Okay. So, this was all about the arithmetic operators. Okay. Now, let's discuss about the other type of operators, which are the comparison operator. Okay. Now, comparison operator compares values and they return true or false. So true or false means they will return a boolean value. Okay. So what are the different comparator operators or comparison operators present in Python? So one is the equal, which is displayed as double equals basically. Now again, the second one is not equals, which is represented with an exclamation mark with a single equals. Then comes greater. Okay. Then comes less, and the other two are greater than equals. Then comes less or equal. Okay. So let's discuss all these operators with again live session. So now this time, let's declare a variable called as x and assign its value as 10, and declare a variable as y and assign its value as 20. Now we will see various different comparison operators. Okay. So first, let's try and print if x is equals y. Okay. Again, let's try and print if x not equals to y. Then let's do the operation of x greater than y, and subsequently let's perform x less than y. Now we are left with two comparison operator, which is x greater than equals to y, greater or equals to y, equals y, and last is print x less than equals to y. Okay, so more or less we know the output, and we'll just try and see if we are getting the expected output or not. Yeah, so for the first statement where we are trying to print x equals to y, so this statement is false and it has returned false because x is 10 and y is 20. Second one, here we are comparing x not equals to y. That's true, and hence it has returned value as true. Now, here we are trying to compare and see if x is greater than y, which is not true because x is 10 and y is 20. Hence, it will return the result as false. In this case, it will return result as true because x is less than y. That is, we can see already. And here we are trying to see if x is greater or equals to y. So this particular statement is false because x is not equals to and also x is not greater than y. So this will return false. And here we are trying to see if x is less or equals to y. So x is less, okay, obviously. So hence it has print the value as true. Now let's say if we keep both these values as equal, then what would be the result? So we have given x is equals to 10 and y equals to 10. Now let's run this file. So see, the output has been changed. Now x is equals to y. That is true. Both are 10. X not equals to y. That is false because both are same. These two statements will also be false because x is not greater than y and x is not less than y as well. But here both these statements will be true because here we are comparing if x is greater or equals to y. So there's this or present, right? So one condition is getting fulfilled, hence it will return the value as true. And for this one also, x less or equals to y, here also one condition is getting fulfilled, hence it has returned the result as true. Okay, so comparison operators are the heart of decision making in automation testing: conditions, loops, and validation. Now let's go on to the another part, which is the logical operators, right? Now logical operators combine multiple conditions. Okay, so there are three types of logical operators: and, or, and not. Okay, now and means, let's say if we are writing in this way, true and false, because we are using an and operator, then to the left side of this operator and to the right side of this operator, both should have the value as true. Then only it will return the result as true, otherwise it will return the result as false. If any one of the condition is not getting fulfilled, it will return the result as false. Okay, now there's this or operator. So or operator says if any one is true, then it will return the result as true. So in this case, if we put or in between, okay, so here the result will be true because any one condition is fulfilled as true. Okay, to the right, sorry, to the left and to the right, any one should be true, then the result should be true. Now not. So this not operator, what it does, it is the reverse basically. So if any condition is getting true and then we are using not, then the result will be false. And if any condition is false and we are using not operator, then it will reverse and give the result as true. Okay, So not is basically the reverse. Example, let's say if we have this value as true, now if we put not in front of it, then the result will be false. So let's discuss these logical operators in little bit more details. Okay, so let's consider a variable age and assign its value as 25. Let's consider another variable called as country and assign its value as India. So remember, this is the integer variable and this is a string variable. Okay, now let's perform some print operations. So wait, here let's type print command, and where age is greater than 18 and country is equals to India. Okay, next line we'll try and print using or operator where age is greater than 18 or country is India. And at the last line we'll try and print if not age is greater than 80. Okay, so see, here we are using and operator, here we are using or, and at last we are using not. So what we've discussed, both sides of and operator should be true, then only the result will be true. In case of or, if any one side of or the condition is giving as true, then the result will be true. And for not, whatever be the result, it will reverse it. Okay, if it is true, it will give the result as false, and if it's false, it will give the result as true. So let's check for this first one. Age is greater than 18, so 25 is greater than 18, this is true, and country is equals to India. So here we have defined a value for this country variable as India. So this is, so both the sides are true, hence the result will be true. Okay, here also age is greater than 18, which is true, and country is equals to India. But here we are using or operator. So if any of these sides is giving true as a result, then the ultimate result will be true. Here age is greater than 18, which is true, but now we are using not operator. So this will return the this will give the result as false. So let's try and check this. If we run this file, okay, for convenience, let me go ahead and remove all these ones. So now if we try and run this file, see, the first two statement gives the result as true and the last one as false. Now let's say if we keep this as age less than 18, now this condition is getting as false. Okay, but here the condition is getting as true. And here also let's make it to age less than 18. Now one condition is false, the other one is true. And here let's do the reverse, age is less than 18. Okay, so now what will be the output? So the first one, now this one condition besides and operator is false, hence the output for this statement will be false. Here still one condition is false, but the other one is still true, so the result will be true. And here age less than 18 is false, but we are using not operator, so the result will be true, as this will reverse the result. So once we run this file, we'll get false for this one, true for this one, and true for this one. Okay, so this is the this is all about the logical operator, and practical usage of this operator can be done if we are having any kind of multiple conditions, if we are doing any kind of login checks, and if we are doing eligibility checks. or to test conditions. Okay, so this was all about the logical operators. Now let's discuss about assignment and compound operators. Okay, so basically assignment stores values. Now if we declare a variable called as x, and if we give its value as 10, so we are assigning value of 10 to variable x. Okay, now compound assignment updates value shorthand. So what it does it means, I'll tell you. For example, if we are using operator as plus equals to, okay, so what we are doing here is we are doing add and assign. So for example, this is like add and assign. Now example could be if we are writing anything like x plus equals to 5, then this is equivalent to x is equals to x plus 5. Okay, similarly, let's talk about minus equals to. So this is subtract and assign. Okay, now again if we write anything like this, x minus equals to 2, then actually what does it means? It means x is equals to x minus 2, right? Now the third one is asterisk equals to. So what does this mean? This means multiply and assign. And if we write something like this, x asterisk equals to 3, it means x is equals to x asterisk 3. Okay, and last one is slash or divide assign. Okay, so slash equals to, so it is also called as divide assign. And if we have something like x slash equals to 2, okay, let me remove the space, then what does this means is x is equals to x divided by 2, right? Now let's discuss this in more details with a live demo. I'll remove this for now. And here let's declare a variable called as num and assign its value as 10. And again, let's declare variable called as num, and here we are giving add and assign, so which will be plus equals 5. Now if we print value of num, what would be the result? Its result is 15. So basically it is written in this way: num is equals to 10 plus 5, because it had initial value as 10. So it has been declared as, so let's like this. Now initially num has this value as 10, so here it will give here 10 will be placed, so 10 plus 5 is 15, hence the output is 15. Okay, let me remove this as well for now. Again, let's have this num num, and then now we will do subtract and assign, so we'll put minus equals to 3. Okay, and then let's print num value. Now this will give the output as, okay, let me remove this. This is not required, just for the explanatory purpose only. Now if we run this file, it has given this time the value or the output as 12. What does this means is now value of num was 15 from this operation, and if we subtract uh, from 15 3, then the output is 12. Okay, Again, now let's do multiply a sign. So for that, we'll do num asterisk equals to 2. And this time let's print the value of num. Now the latest value of num is 12. And here what we are doing, we are trying to multiply 12 by 2. So the output should be 24. So let's find it out. Yes, so the output is 24. And at last, we are doing divide assign. So num slash equals to 2, and then let's print the value of num. So till here the value of num was 24, and then we are trying to divide 24 by 2. The value should be 12. So if we run this file, we get the value as 12. So this is extremely useful in counters, loops, automation retries, and scoring system. So wherever you are using any counters or loops or automation retries in your code, so then in that case, this assignment operators or assignment and compound operators, they prove to be very useful. Okay. Now, the other type of operator is called as membership operator, and it is used to check value inside sequences. Okay, so there are two types of membership operator. One is in, and what does this means is it means present, right? So to check the value inside a sequences, so if you're using in operator, it means the value inside sequence is present, and if we are using not in, then value inside sequences is not present. Okay, so let's discuss this as well with some practical example. This time let's declare a variable called as name and assign its value as python. Okay, and in the next line let's try and print this statement where print, and in double quotes we are providing py. Okay, and we are using in operator in name. So what we are trying to check is if py is present in name, like this value. Okay. Now let's print another statement where we are trying to check if Java is present in name. So if we run this file, the first statement will be true because py is present in Python. However, the second one will be false as Java is not there as part of this particular value. Again, let's consider an example where we declare a variable called as my underscore list, and we provide these values inside the list, which is 1 comma 2 comma 3. If we try and print the statement where we are checking if 3 is there in my underscore list variable, and let's do another print, and here we'll check if 10 is if 10 is if 10 not in my list. So here we are using in operator, and here we are using not in operator. Now if we try and run this file again, okay, let me delete this one. So the output will be clearly visible. So yeah, so both these values are coming as true because 3 is present in this list, which is 1 2 and 3, but 10 is not present in my list variable. Now if we reverse this and if we do not in, and let's have this as in operator, then the output will also get reversed. So 3 is present in this my list variable, but here we are saying 3 not in my list, which will eventually be false and the output will be false. And 10 in my list, here we are saying 10 is present in my list variable, which is not the case, and hence the output will be false. So this membership operator is used in form validations, text search, list checking, so on and so forth. Now next operator is the identity operator. Okay. So here this operator checks memory identity and not the value, unlike the membership operator. So there is again two operator for identity. One is the is, meaning same object, and the other one is not, which means different object. Okay. So what does this means? Let's check with an example. So let's consider a variable called as a and assign its value as 10, another variable b, and give this value as 10 again. Now if we print a is b, so what would be the output? Let's check. We'll remove this again for now and see what should be the output now. Now a is b, so a and b have both equal values, so a is b will return true. Now if we use a is not b, then this clearly contradict the statement, because both a and b has the value as 10, which are same, so this time it should return false. See, it has returned false. So this is all about the identity operator, and in real world it is useful in object identity framework instances. Okay. So with this we have covered up all the possible operators which Python provides. Okay. And we can have this used in real world connections, where we are checking conditions in Selenium, API status checks, loops and decision making, login validation, and business logic. Right? Now, if we conclude this whole operator thing which we've just discussed, so the key takeaways would be: operators allow Python to calculate, compare, decide, and core families of the operators are arithmetic, comparison, logical, assignment, membership, and identity. Okay, so I'll conclude this whole video with a line like: if data types define what your data is, operator define what you can do with it. Hello and welcome back to Black Box QA again. And in this video, we will be learning about what are list, tuples, set, and dictionary. So combining them all together, so the concept of collection comes into picture, right? So far we've seen variables storing one value, but in real world programming, we deal with multiple values together, like list of users, product catalogs, exam marks, drop down values, etc. So let me ask you a question. If I want to store marks of 5 student, will I create 5 variables? Yes, you can create 5 variables, but that won't be a best practice, right? So hence the concept of collection got introduced in Python. Okay. So Python gives us 4 powerful collection types, which are lists, tuples, sets, and dictionaries. Okay. So first we will discuss about what lists are. Okay. We'll clear this out. So lists are the most commonly used collections in Python, and if we talk about their key characteristics, so lists, first of all, they are ordered. Second, They are index based. Third, they are mutable. That means they can change the values. And fourth point is they allows duplicate values. Okay, so these are the key characteristics of lists in Python. Now, if we talk about its syntax, it's the square bracket. Okay, so let's understand the concept of list in more details with some examples. Okay, uh, let me declare a variable called as marks. Okay, now this will be a list variable and we'll define its value inside the square bracket. So let's consider we provide four values to it, which are as 90, comma, 85, comma, 92, comma, 88. So we have declared a variable called as marks and we have all these values declared as list. So there are a total of four values. Now if we print this marks, so what output we'll get, let's see. Yes, so it has printed its values which are 90, 85, 92 and 88. And if we try and print its type, and now let's see. So it says it's class list. Okay, so this is a list and Python prints it exactly the way it is stored. So the sequence is also the same if you look at it: 90, 85, 92 and 88. Okay, now the second point comes is if we want to access any specific list element. So first of all, let me tell you, so while storing these list elements, an index is assigned to all the single respective list elements. So what does this indexing means? It's basically we'll mark it as 0, 1, 2 and 3. So at 0th index value 90 is stored, first index value 85, so on and so forth. Okay, so let's try accessing the list elements present for marks variable based on their index. Okay, so for that we write marks, we'll provide the variable name, and inside the square bracket we'll provide the index. Let's put 0 for now and let's see what the output is. So see, at the 0th index we have the element 90 present, so hence it has printed out 90. Okay, let's try and see what is present at index 1. So at index 1 it's 85, hence it has printed out 85. Now to get the last element in the list, we can also have this arrangement where we can define the index as -1. So if we run this file, the last element in the list has been printed out, which is 88. So this is one way. The other way is the usual one. So let's consider the indexing starts with 0. So 0, 1, 2 and 3. So if we put 3 over here and if we print this, then also we'll get the value as 88. So -1 refers for the last index in the list element and it will print the element present at the last index. Okay, similarly if we provide -2, then this will refer to the element present at the second last uh, place of the list. So in this case if we provide -2 it will print 92, so on and so forth. Okay, so both positive and negative indexing we can provide. So if we provide positive indexing, it starts from left to right, and if we provide negative indexing, it starts from right to left. So this is the difference. Now we have seen that one of the feature of list is it's mutable. Okay, so let's try and modify this existing list. Mutable means whose values or sequencing of the elements can be changed. It can be added, it can be deleted, so on and so forth. So let's check this with an example. Now we'll take this variable name as marks, and at the first index of this marks list, what we are doing is we are assigning a value of 95. And now if I try and print this marks again, okay, so initially the value or the element which this marks list hold was 90, 85, 92, and 88. Now at the first index, we are assigning this element whose value is 95. And now we are trying to print the marks. So let's see. So what happened is initially, at the first index, the value was 85. Now, after assigning or changing the value to 95, now the new list of elements which has been displayed here is 90, 95, 92, and 88. So this means that list can be mutable, and we can change the elements or the sequence of it. Now, let's discuss about adding and removing values also. So again, we will take this variable name, list variable name, and we'll put a dot. Okay, with this it suggests all these functions which can be done. Okay, which has reverse, remove, insert, extend, clear, append. Okay, all these functions are provided with list. So let's use append. Okay, now what we are doing inside this small brackets, let's give a value as 99. Okay, so what does this means? Now let's see if we try and print this again, and if we run this, we'll get the output as this. So this is the modified list. So append means we are appending 99 to the existing list. So existing list is 90, 95, 92, and 88. And after appending 99, so total number of elements now has become 5, and 99 has been appended at the very last index of the list, right? So if you are appending any new element to the existing list, it gets appended at the very last. Okay, not in between, not at the beginning, but it will be at the very last. Okay, now if you want to remove any existing element from the list, so for that we will use this function called as remove. Okay, and let's remove 92 from the existing list. And now, okay, this should be marks and not mark. Now if we try and print this list again, you will get to see that 92 has now been removed from the existing list, and now again there are four elements with 92 being removed. Okay, so these are the two functions which we have discussed for list. Now let's discuss about insert. Okay, so let's type marks and put a dot, and here let's use this insert function, and this accepts two parameters, so separated by comma. For now let's give 1 as one of the parameter and 100 the other parameter. And now if we try and print marks, okay, before that, so if you see the two parameters which I was talking about, so the first one is the index and the second one is the object. Now we have given 1 in place of index, means at the index 1 we are trying to insert 100. Okay, so that means now this is our existing list which has 4 elements: 90, 95, 88, and 99. And if we try and insert 100 at the first index, there will be 100 inserted between 90 and 95, and all these rest of the 3 elements will be shifted further. So if I run this file, see, 100 has been inserted in between 90 and 95. That was, so 95 was at index 1 initially, but now it is at index 2, and 100 has came at index 1. Okay, so we have discussed about three functions. One is the append, then insert and remove. So append adds the new element at the very end. Insert adds it at the position which we provide in the parameters. For example, we have given one. And remove removes first matching value. Okay, so that's about the three functions which we have discussed about list. Now let's discuss about looping through list. So for example, let's create a for loop for m in marks colon. Now here we are trying and print m. So let's see what happens. Now looping through list, so what it will do, it will print each of the element which is present in the existing list, one after the other. So it will print 90, and a new line it will print 100, and so 95 will be printed, 88 and 99. Okay, so this explains this whole thing which we have discussed about list. So lists are perfect for data processing. And if I talk about some real world examples, so for example, if you are dealing with any kind of shopping cart items, or if you are going or dealing with any kind of report cards which include student marks, or web table row values, and from the drop down list. So in all those cases, we will be using list. Okay. Now let's discuss about other type of collection which is called as tuples. Okay. Again, if I talk about its key characteristics, so tuple is ordered. Okay. Wait. Okay. So tuples are ordered, and they are index based, and they are immutable. So unlike list, they are immutable. That means they cannot be changed. They cannot be changed. Okay. And fourth characteristic is they are faster than list. Okay. And the fifth one, if I talk about, so they are used for fixed data. So where you are dealing with fixed data which do not require any change, so in those cases tuples can be the best fit. Okay. Now we have discussed about its characteristic. Now let's discuss few examples, but before that, syntax of tuple is small brackets. Okay. However, for list it was square brackets, but for tuples the syntax is small brackets. Now let's create a variable called as point, tuple variable, and give the element value as 10 comma 20, comma 30. Okay, so we have created a variable with variable name as point and tuple variable basically, and we have defined three elements whose values are 10, 20, and 30 respectively. If I print this point, and in the next line if I try and print its type, okay, so it will give the output as 10, 20, 30, and class as tuple. Okay, again here also, if we check for the index, now just like in list there are also indexing associated with tuples, and if we want to access any particular element at any given index, then for that you need to type print and point at zeroth index. So whatever value is present at the zeroth index, that will get printed. So when I run this file, at zeroth index we have 10, hence 10 got printed. Similarly, for 1 it will print 20, right? And for 2 it should print 30. Same way, if you want to have negative indexing, so let's put -1 over here, and if I run this file, it will print 30, right? uh, like what we have seen in case of list, same goes here with case of tuples. Okay, now talking about the immutability, so unlike list, tuples are immutable, means they cannot be changed. Now in list, we tried inserting an element at a given index in the existing list. So here we have, in case of tuples, we have these elements 10, 20, and 30. Let's try and insert at index 1 element whose value is 50. So see, uh, if I try and print this print point, and if I run this file, see, I'll get an error saying tuple objects does not support item assignment. Means it's a considered as a type error. Or you can say tuple value cannot be changed, and if data must stay fixed, then we can use tuple. We can go for tuple. And real world usage would be in case of coordinates. If we are dealing with coordinates, so coordinate values remain same, and so there we can use tuples. And second, we can use for any kind of configuration values. Third, we can use in case of constant data, and also we can use tuples in case of database records. Okay, so let's say if I ask you a question, if you want data that should never change, so which one will you choose, list or tuple? So obviously, as we have discussed about list and tuples, so for this our answer should be tuple. Okay, that was all about tuple. And if I talk about sets, so which is third type of collection in Python, so let's talk about its key characteristics. Okay, so first characteristic is it's unordered. Then second one is no indexing. So unlike list and tuples where indexing is involved and we can access the elements using the respective index, here for sets there is no concept of index. Okay, and they are unordered as well. So while list and tuples were ordered. Okay, now third characteristic is no duplicates allowed. In case of list and tuples, duplicates were allowed, okay, but in case of sets, no duplicates are allowed. Fourth characteristic would be used for uniqueness checks, and fifth one would be it has very fast operations, means it's faster than list and tuples. Okay, so these are the basic characteristic of set used in Python, and its syntax is curly brackets. Okay, so let's discuss few examples. Now this time let's create a set variable called as numbers and create this set where the elements are 10, 20, 30, 40, and 20. Okay, now if I try and print number, so if I run this, see, if you look at the output, only 40, 10, 20, 30 has been printed. What about the other 20 which was there in the set? So now, as we've seen or read through the characteristic of sets, that no duplicates are allowed. So while providing the output, duplicates automatically gets removed, and that's the power of sets. So if let's say by mistake if you have added any kind of duplicate values or duplicate records, then those duplicate will automatically get eliminated or removed. Okay. Now let's try add and remove the existing element in the sets. Okay. So again, we will use number, and if I put dot over here, so all these functions are provided for sets. Now let's use add. So for this, let me provide a value as 60, and let me remove one existing value from the set. So we'll use remove, and here inside this I will be removing value 30. Now if I print this again, so this will be the modified list. So 60 has been added in the existing list and 30 has been removed. So in place of 30, we'll have a new element called as 60. Okay. Now this means that no indexing like list is needed in case of sets, and order is also not guaranteed. So that we have seen in the first run itself. So see here we had this element which started from 10, 20, 30, 40, and then we had 20. So if we run this, and if the set would have been ordered just like lists and tuples, so then the sequence would be 10, 20, 30, 40. Huh, we can remove this 20 as it was duplicate, but still the order should have been the same. But now the order is not guaranteed. Hence, you can see in the output also, first it has printed 40, then 10, 20, 30. Okay. So this is also one such characteristic of using sets. Now, if I talk about using for loop for sets, so let me declare this statement for n in number, and if I print n and if I run this file, so it has printed the existing elements of set which started from 40, 10, 20, and 60, each in a new line. Okay. Now if I talk about the real world usage for sets, so they can be used for unique users. In case of removing any duplicates, we can use sets, And for validating any unique values, we can go for sets. And for fast membership testing, as we have seen, set has a very fast performance when compared to the other two collections in Python, which are list and tuples. Okay, so if you only want unique values, which collection would be the best? So answer is set. We'll go with set. Okay. Now let's talk about another topic which is called as dictionaries. So this is also one such collection in Python. So if we talk about its key characteristics, then first one would be like it stores in key value pair. Second, second would be like a real world dictionary. Okay, so this works as a real life dictionary. And third is for fast lookups, we go for dictionaries. And fourth one, here no duplicate keys are allowed. However, values can be duplicated. Okay, so these are few of the important characteristics for dictionary. And if we talk about its syntax, so syntax is like this. Inside curly brackets, we are defining key and value. So basically, inside curly brackets, we are defining key and value pair. So this is the syntax for dictionaries. Now let's discuss few examples around dictionaries. Okay. Consider a variable name called a student, and if we provide, if we are declaring this variable for dictionaries, we will be having the elements in form of key value pairs. Okay, so yeah, let's take first key value pair when name is equals to Rahul, means name is a key and Rahul is the value. Let's consider its age as 18, and let's consider another element called as marks as 92. Okay, so this we have just declared a variable in dictionary, and if we print this variable name, and in the next line if we print its type, okay, then let's see what would be the result. If we run this file, so we have this output as in form of key value pairs again. So name as Rahul, age as 18, and marks as 92. And it belongs to class dict, which is dictionary. Okay, so dictionaries store data in the form of label values, or you can say in form of key value pairs. Now here as well, if we try and access any element from the dictionary, so for that we can use print student, which is the variable name. Okay, and inside square bracket we will provide the value, we will provide the key name basically. Okay, so let's go with key as name, and in the next line let's try and get the value for age. Okay, so here we will be defining key, and if we go ahead and run this file, we'll get the output of the respective value. So see, for name we had value as Rahul, this got printed here, and age as 18, and 18 is printed over here. Okay, so this is how we will be accessing values for dictionary using the keys. Okay, so instead of indexing that we have seen in case of list and tuples. For accessing values in dictionaries, we will be using keys. Okay. Now let's see if we can update dictionaries or not. For updating dictionaries, let's try this statement, which is student, and again we will be using key. So let's go with key as marks, and in here, instead of 92, which was initially been assigned value for marks, we are giving 90 this time, and then we are trying to print student. Okay, let's see what would be the output if we run this file. Now this time, initially the marks has been assigned value as 92, but after changing it, it has updated the value as 90. So that means we can update the dictionary. So it's, you can say, mutable. Okay. Now if we talk about adding new key, okay, to the existing dictionary, so for that, what we will be doing, we will be writing this student variable name, okay, and inside square bracket we will give another key name as city. Okay, and let's assign this value as Pune. So we have created another element in the existing dictionary with key name as city, and we have assigned city a value called as Pune. So if we try and print student again, let's see what happens. So this time, see, along with the existing one, which was name, age, and marks, a new key has been added called as city, whose value is Pune. So this way add we can add new elements to the existing dictionary. Now if we are able to add it, then we can also remove the values as well from the existing dictionary. Okay, so for that there is a method which is called as pop. So if we type student dot pop, okay, and if we give or you can say any key value, sorry, any key name. So let's go with marks, and if we print this dictionary again, so marks entry would have been disappeared now. See, if we look at the new value, we have keys as name, age, and city. However, marks which was there in the existing dictionary has now been removed. So using pop, you can remove any existing key also. Now, if we use loops in dictionary, so for that, let's use for loop. So for key, comma, value in student dot items, okay, small brackets, colon, and if we print key, comma, then we'll have this equals to, then we'll put value. So it will so what it will do, it will go through all the key and values, and it will print one by one. So if we run this command, okay, so we have a kind of an indentation error, okay, unresolved reference key. We'll put this as small. Okay, now it's all good. And if we run this again, so see, it has now printed the first entry for name, the second one for age and city, one by one, one after the other, in each new line. So this way we can use loops in case of dictionaries as well. Now, if I talk about the real world usage where dictionaries can be used, so those can be used in case of API responses. So, if you have worked with APIs, then you might be knowing that once we hit any API and we get any response, so those responses in the form of key value pairs, or in other words, we call it as a JSON format as well. Then, in second case, we can use dictionary for JSON data. Okay, also, we can use dictionary for user profiles, and then we can use it for configurations, and last we can use it to test data storage. Okay. Now, if I ask you, like, where do you see dictionary like data daily? So, as I mentioned, if you have ever worked with APIs, so in that case, for example, let's talk about doing a post request. So the request payload also comes in form of JSON, which is key value pair, and the respective response also we receive in form of JSON, which is again a key value pair. Okay, so I would say that was the entire collection which comes for Python, and if I summarize this list, tuple, set, and dictionary, so it would be like this. So, list, if it is ordered or not, yes, lists are ordered. Lists are mutable, that means it can be changed. If it allows duplicate or not, so yes, list allows duplicate. And use case would be general data. Now, if we talk about tuple, so tuples are also ordered, but they cannot be changed, means they are not mutable, and they can also allow duplicates, and as they are not mutable, their use case would be wherever fixed data are required or processed. Now coming to set, so sets are not ordered, means if you are getting the output for any kind of set, so as we have seen, the ordered is not guaranteed, so they are not ordered. Mutable, yes, they can be changed. And does they allow duplicates, so that also we have seen, if there's any duplicate entry in the output, it gets automatically removed. So sets do not allow duplicates. And in use case, we can work with sets for unique data. Now, if we talk about dictionary, so dictionary also they do not have any order, but from Python version 3.6 and above, we need to have this insertion in order. Okay, but before 3.6 there is no order. Okay, for dictionary. Now if we talk about if it's mutable or not, yes, it's mutable. We have just now saw an example. And if it allows duplicate, and here we can see only the key should be unique, while the values can be duplicate in case of dictionary. And for use case, we can have it being used wherever we have this key value form of data. So this was all about the collections in Python. We have discussed about list, tuples, and set. So with this, I want to conclude this video saying like list helps store multiple values, tuples ensure safety, sets ensure uniqueness, and dictionary gives meaning to data. So that was all for collections in Python, and thanks for staying up till here. And if you like this video, please like and subscribe, and thanks a lot. Hello everyone, and welcome back to Black Box QA again. So agenda for this video would be, here we will be understanding about the conditional statements in Python, along with we will see about all the loops, which are there in Python. Okay, so let me start this video about asking a question. Okay, for example, let's say if you fail an exam, so do you celebrate or study more, right? So that's exactly what conditionals do. So they make decision, right? And loops help Python repeat tasks without getting tired. So I would say programming isn't just about storing or calculating values, which we have seen in the previous videos. Hence, real programming is about making decisions and performing repeated tasks automatically. Okay, so if we go ahead and talk more about the conditional statement, so conditionals allow Python to behave differently based on conditions. So if I talk about a simple flow which says if condition is true, then you have to perform something, else you do something else. Okay, so if you have worked with any other languages such as Java, there also you might have heard or worked with if else statement. So Python also has more or less the same objective of using if else statement. Now let's consider an example. Okay, so here we will declare a variable called as age and assign its value as 18, and we'll use if else statement over here. So we'll write if age is greater than or equals to 18, then print you are eligible to vote. Okay, so here we have declared an if statement where where we are checking if the age is greater than equals to 18. Then we are doing a print statement and giving the text as you are eligible to vote. So here if you see, Python does not use curly braces like other language. Okay. Instead, indentation defines the block. So if you see here, we have not used any kind of curly brackets. Simply, the indentation defines the block. Now, if we run this file, then it's printed you are eligible to vote. Now, what if the age has value as 16? In this case, this condition not stands valid. Here we are checking if age is greater than equals to 18, but our age is now 16. So what will happen? If we run this, so nothing will be printed out because we haven't directed Python to print anything else if the condition does not fulfill. So then comes the concept of else. Okay. So let's say if we type else, now if this condition is not fulfilled or stands invalid, then we are directing Python to print you are not eligible to vote. So in this case, now initially it hadn't done anything. Now if we run this file, it will say you are not eligible to vote. So now Python knows what to do even when the condition is false. Okay. Let's take another example and discuss about if, elif, else. Okay. So let's say life is not always binary, not just yes or no. Sometimes we have multiple possibilities. So let's discuss those possibilities with a live example. Okay. So for that, let me delete this first and create a variable called as marks. Okay, so in here we will give marks a value as 75, and let's write this if statement. So if marks is greater than or equals to 90, hmm, then let's perform this print operation. Print, you are excellent. And in the elif statement, if marks is greater than or equals to 75, okay, then what we will say, we will print you fall under the category of very good. And let's have another elif. Here we'll say if marks is greater than equals to 50, then you fall under the category of pass. Okay. And let's say if you do not fall into any of this category, we'll write else statement and say you have failed the exam. Okay, so before that, let's check why this error is coming. Basically, it's because of the indentation. So make sure your Python code complies with all the indentation. So we'll just keep it, we'll give a backspace, and now everything looks good. So now we have defined marks as 75. So where it should uh, fall? It should fall under the category of very good. So if we run this command, so see, very good has been printed out. Same case goes with if we change the value to 49, let's say, which does not fall into any of these three categories. In that case, the condition now has printed fail, means it has not fall into any of these three categories, and it has printed else statement which says fail. Okay, so what will print if marks is equals to 95? Let's check that out as well. So in that case, here this condition will get fulfilled, where we are checking if marks is greater than equals to 90, and we will get the output as excellent. Okay, so now you might be getting the idea about using if, elif, and else statement. Okay, now let's talk about logical operators in conditions. So for that, let me give that demo with a quick example, and let's declare a variable as age having value of 20, and let's define another value called as country and give its value as India. Okay, now we'll have this if else statement where we are checking if age is greater than equals to 18 and country is equals to India. So pay very attention to this particular operator, which is and this is one of the logical operator. Okay, now we have given the statement if age is greater than equals to 18 and country is equals to India, then let's print the statement that you are eligible to vote in India, right? So now as we have used and, then that means both sides of and the condition should be true, then only this whole condition will be fulfilled and stands valid, and it will print whatever is there just below it. Otherwise, if any of this condition stands invalid, the print statement won't be executed. So let's try and run this and see what will happen. So see, it has printed out you are eligible to vote in India. If I put age over here as 21 and run this, so nothing will happen because our initial value of age is 20, and here we are checking if age is greater than equals to 21. So this condition stands invalid. And as we haven't declared anything in else or elif block, in that case, what will happen? The Python will not do anything. Okay. Now, let's say if we would have used or in place of and. So, what does or means? If any one condition around or stands valid or true, then this particular print statement will get executed. So, if any one condition should be true, and that should be sufficient, right? So, if we run this now, so see, it has printed you are eligible to vote in India because this particular condition still stands valid if country is equals to India and we have this variable called as country whose value is India. Okay, so this was the logical operators in conditions. Now, if we talk about the real world examples of if, so where exactly we can use if statement. So while working with automation frameworks, there will be n number of conditions where if we use if statement, our code will become much more robust. So those examples can include, for example, login validation. And if you are doing any kind of payment, then you have to check whether it's been successful or it's been failed. At those places you can use if. And showing an error message, so if you are executing any code and see if you have received an error, so at those places also if statement can be used. And also you can use at places where age and eligibility checks are involved, right? So conditionals brings intelligence to your program. So if you are using if statement or any conditional statements, so as I mentioned, your code will become much more robust, and that brings intelligence to your program. Okay. So that was all about the conditional statements in Python. Now let's discuss about loops as well. So what are loops? You might have worked with loops in working with any other languages, for example, Java. So there we have used while, do while, for all these loops. So same way in Python also we'll be using those loops. So loops help Python do things again and again without writing the code again. Means, and also it's always a best practice to use loops so that you can avoid repeatability in your code, right? And also it's also of not much use if you are writing your code again and again doing all those manual stuff. It's bit time consuming as well. So in place of that, you can use loops, right? Now let me clear this out with a question. So if I want to print numbers from 1 to 10, will I write print 10 times? You can do that, but still it's not a best practice, right? So let's say if I want to print numbers from 1 to 10, so I'll be keep doing this activity: print 1, then print 2, then print 3, then print 4, so on and so forth. So anyways it will execute. See, you have numbers printed over here, but why to do all those repetitive tasks when you have the privilege to write it once and execute it again and again? So we don't repeat code, we let Python repeat using loops. Okay, so this will get more clear with this example. So for example, first let me delete this. Let's write a for loop for I in range 1 6. Okay, then print I. Now, here what we are doing, from the range 1 to 6, 1 being the lower range and 6 being the higher range. Here we are directing Python to print all the numbers which comes between 1 and 6. So if we write or if we run this code, see, it has printed 1, 2, 3, 4, and 5. So in 2 lines itself, we have printed these all 5 numbers. We can increase the range as well. Let's say if we want Python to print the numbers in the range from 1 to 10, And if we run this, it has printed all the numbers in the range 1 to 10. So let's say if we would have did it in the previous way which we have discussed and which was not the best practice also, you need to write the same print statement 10 times to print all these numbers differently. But here in the two lines itself you are solving the purpose, right? So here it will start with 1 and it will stop at 9, and hence we got the output from 1 till 9, and the loop is running automatically. So what if you want to run from 1 to 20? So same way, you just need to change this higher limit from 10 to 20. And if you run this file again, so this time it has started with 1 and till 19 it has printed all the numbers, right? Now, this was one way of using for loop. Now, let's say you have a list variable, right? We have discussed about lists and other collections of Python in our previous video. So, what will happen if you are using any collection variables? So, let's take an example of list and try running for loop for them. So, for that, let me create a list variable called as fruit. Okay, and inside let's give all these fruit name as elements, which is apple, banana, cherry. Okay, and if we run for loop for this, where we will write for f in fruits. Okay, and then we'll print f. So okay, I'll remove this extra s from here. Okay, now what will happen if I run this file? It will print all the elements in the list one after the other, like this: apple, banana, cherry. Okay, so this looping is best, or you can say is perfect for collections, and it's used widely in automation where we will be using loops to read table and their values, drop down options, etc. etc. So we've discussed about for loop. Now there's another loop which is called as while loop. And while loop is used when conditions based repetition is involved. Means it's the best fit wherever the condition based repetition is involved. Now while loop repeats until a condition becomes false. Now what does that mean? Let's get that understanding with an example. Okay. Now let's declare a variable again, num, and assign its value as 1. Okay, so we'll be writing while loop with while num is less than or equals to 5. Okay, then print num, num plus equals to 1. So what we are doing is we have declared a variable num and has assigned its value as 5. So what it will do, this particular statement, while num is less than equals to 5, so what it will do, it will keep printing the value of num until unless it becomes equals to or greater than 5. Okay, so here at the last step we are increasing the value of num also by 1 with each repetition, right? So first time the value of num will be 1 and 1 is less than 5, so this print statement will get executed and it will print 1, and at the last step the value of num will then become 2 because it has increased with 1. Next time it will go again, this time the value of num is 2, and this check will be made, which is again valid one because 2 is less than 5. Again the same thing will happen until unless value of num becomes 6, because if value of num becomes 6, so it's neither less than and nor equals to 5. That time this condition will become false and the loop will be stopped. So if we run this file, see, it has printed 1, 2, 3, 4, and 5. So as soon as the value of num became 6 and once it validates this condition, so 6 is neither less than nor equals to 5, the condition stands invalid and hence the loop will stop. Hence, the condition of while loop is validated, which says while loop repeats until a condition becomes false. Okay. So, what will happen if we forget this last line over here, right? Let's see. If we remove this line, so what will happen? Python will keep running forever and this will become an infinite loop. Okay. Because see, every time the value of num will be 1 and 1 is less than equals to 5, which is valid, it will keep printing on num without breaking the loop. So if I run this, see, this will go on forever and ever and ever and ever. It will keep printing 1 infinite times. So we have to stop this. Okay. So that's why it's important to provide certain conditions so that the while loop does not run infinitely. With that, let's discuss about the concept of keyword break, continue, and pass. Okay. So first, let's discuss about break. So it's a simple keyword which is written like this: break. Now, break, what does this will do? So break will stop the loop immediately. For example, if I take this break keyword in case of for loop, so let's uh, describe the statement for loop for I in range 1 comma 10. Okay. And we are also doing a conditional check. If I is equals to 5, okay, then break, we will provide break. And at the last step we will do print I. Okay. So what it will do, here we have seen in while discussing for that, if we type only this particular statement, for statement, it will start printing the numbers starting with 1 till 9 in the range 1 till 10. Now we are also providing a conditional check. So as soon as I becomes 5, means I starting from 1, so at some point in time it will have a value of 5 as well. So as soon as I becomes 5, a break has been provided, so it will break this loop. It won't execute till the end, means all those number after 5 like 6, 7, 8, and 9 will not get printed, and whatever was there from 1 till 5, those numbers will only get printed. So let's check that value. See, we've got these output because as soon as I became 5, it has break this loop, and the value of I as 5 has not been printed out, right? So only numbers starting from 1, 2, 3, and 4 has been printed. Okay. So break is like saying stop loop now. Okay. So as soon as you apply brakes to your car stops, right? Even if you want to, if even if your destination has not been arrived, once you apply brake your car gets stopped. So is the case with brake over here as well. Now there's another keyword called as continue. Now continue, what does that do? So continue is skip one iteration. Okay. So what exactly does that mean? Let's take an example. Okay. Let's take this example only. So for I in the range of 1 to 10, if I is equals to 5, then instead of break, let's provide continue. Okay. And then we are printing the value of I. So if I run this file, what will happen? So see, it has started printing the numbers from 1, 2, 3, 4, and you will see 5 has been skipped. And after 5, 6, 7, 8, and 9 has been printed out. So what does that mean? As soon as I became 5, it has asked Python to skip this iteration where I is equals to 5. Rest you can print everything else. Okay. So basically continue says skip this turn and move to the next, right? And similarly there is this another keyword called as pass. So pass, what does it do? It do nothing. So it's basically a placeholder. Okay, so we'll keep this same example, and for I in range of, let's say, 5. Okay, and if we provide pass, then what it will do? So if we run this file, nothing will get printed out. So same way as I mentioned, do nothing. So pass, its function is to do nothing. So basically used when you want a structure, but logic is not ready yet, so it's kind of a placeholder. Now what needs to be printed, that logic you haven't written yet. So you can put pass over here so that it doesn't look weird also, and later on you can apply the logic. So till then this pass will act as a placeholder. Okay, now this was all about the loops in Python. Now, as a conclusion or concluding this video, conditional statement let Python makes decision, while loops let Python repeat tasks automatically, and together they make your program smart and efficient. Okay, so before concluding this video, let's have a quick recap. So we've seen how if, elif, and else works. We have seen how for loop works with variable as well as collections. We have seen how while loop works, and we have also seen the functionality of break, continue, and pass. Now, without conditionals and loops, programming would be boring, and it will be a lot of manual and repetitive work. So, with them, Python becomes intelligent and powerful. Okay, so with that, I'll conclude this video. And if you have liked this video, give a thumbs up and share and subscribe. Thank you so much. Hello, and welcome to Blackbox QA again. So, in this video, we will be discussing about the functions in Python, okay, the modules, packages, exception handling in Python, and also we will be discussing about the global and local variables in Python. Okay, so till now we wrote code sequentially, right? But in real world projects, so those require organized, reusable, and maintainable code. Let me ask you a question. If you need the same logic 10 times, will you write it 10 times? Obviously, you can write it, but that would not be a best practice. So, the answer is no. And that's why we use functions, modules, packages. And when things go wrong, we handle them using exception handling. Okay? So, let's begin. What is a function? Okay, so by definition, if we go, a function is a block of code created once and reused anytime. Now, what would be its benefit? So benefit includes reusability, clean and structured code, reduces duplication, and makes debugging easier. Now let me discuss that with a syntax. Okay, so before that, let me create another file and let me name it as functions. Okay, so if I discuss about the syntax of function, if I write the syntax of function, so function syntax, basically it starts with def. Okay, and then it has the function name, and inside the small bracket it has parameters. Okay, and after that a colon, and then the block of code. So whatever code you want to write, so those will be written under this function. So it starts with def, then a function name, and then the parameters that needs to be included. Following, there will be block of code. Okay, so let me make it more clear. with uh, with an example of a basic function, right? So let me create a function with a function name called greet. So we'll write def, and we'll write the function name as greet, and then small brackets. Here we are not providing any parameter, so I'll leave it as empty. And then let's do a print which says hello world. Okay. Now, if I run this file, so see, nothing has been given as an output. We have just declared a function, we have written the code, but in output, there's nothing came while running this file. So what does that mean? So in order to execute any function, you have to call that function as well. And to call a function, you have to write simply its function name and followed by small brackets. Now, if I run this file again, you will see what we have printed over here. What we have given text hello world, the same has been printed over here, right? So, did the function executed when we defined it? No, right? So, it is executed only when the function is called. Let me give you another example. Now, this time, what I'll do, I'll provide parameters also inside the function. So let me declare another function with a function name as welcome. And this time, let's give parameter as name. Okay. And now we will be printing hello. We'll be printing hello. And here we will be giving the parameter name. Now, in order to execute the function, we have to call it. So we'll write function name, and in place of parameter, let's give any name. So for example, let's give here as Rahul, and again let's call this function. This time let's give the parameter value as Priya. Okay, so if we run this file, so this function was called twice with different parameter value. So first it will print hello Rahul, and then second time it will print hello Priya. Okay. So what does that mean? So this means that function takes input and that works dynamically. Okay. So as an input, we have provided the person's name and it has worked dynamically. Now, if I ask you, can I pass different data every time? Then what would be the answer? So the answer would be yes. You can pass different data types also. Okay. Now, let me discuss another example. This time, let me create a function with a function name as add. And here we are giving two parameter values. So let's give a as one of it, and let's declare another parameter as b. Okay. Now, as this will be a mathematical operation, so we have to return the value also of the operation which we'll be performing with these two parameters. So let's write return a plus b. Let's do this. Okay. Now, in order to execute this function, we'll call this function, but for that, let me create a variable called as result, and this will be the variable where we will be storing the operation. Okay, so we'll call this function now add, and let's give the parameter values for a and b as 1 and 2. Okay, and at last we will be printing whatever value has been stored in the result. So let's print that, and once we execute it, we will get the output of 1 plus 2, which is 3, right? So now in this function we have used return statement. So what does this will do? So return sends data back, and without return, function will give nothing. Now let's discuss the types of function. Okay, so if I talk about the type of functions, so there are certain built-in functions, for example print, len, type. Then comes user defined functions. So those functions are the ones which we create them. So for example, over here, the function which we have created was add, and this can be considered as user defined function. And the third type is lambda functions. So that's an advanced topic and we'll discuss it later in some time. Okay. So today we will focus on user defined functions and lambda will come soon. Now, coming to the another part of this video, let's talk some points about local and global variables. Okay, so some variables live inside a function, other live outside and are accessible everywhere, right? So if you have worked with other languages such as Java, there also you might have encountered this concept of global and local variables. So the variables which we declare inside a function, so that are called as local variables, and the variables which we declare outside of a function, so those are called as global variables and they can be accessible everywhere. So let me explain this with an example. Okay. So for that, let me create a function called as show, and let me create a variable called x and assign its value as 10. So now let's print this particular statement inside function comma x. So if we call this function in order to execute it, so we will write its name followed by small brackets, and here let's print x. Okay, so let's first run this file. So we will see an error over here which is pointing to this particular part of the code, and it says name error, name x is not defined. So why this error came, and because everything else looks good. So that means that x is local to function and outside world cannot access it. So here we have declared a function and x was local to this particular function. Now when we tried calling it outside this function, it gave an error and said name x is not defined. Reason being, x was local to this function only. Now, similarly, let's talk about global variable also. So, in global variables, uh, as we know, global variables are accessible inside and outside of a function. Let's talk about it with an example. Let's consider a variable name called as x, and we assign its value as 50. Okay, and then now create a function called as show, and let's print this particular statement inside function. And over here we'll give the value of x, and now in order to execute this function, let's call it show, and in the next line we will be printing this particular statement which says outside function. Okay, now this time we have declared x equals to 50 as a global variable, and then we have created a function, and over here we are trying to print the value of x inside this particular function. And after executing this function, we are again calling this x outside the function. So let's see if this gets executed or not. So if we run this file, see, both the print statement has been executed successfully. Reason being, we have declared x globally, and global variables are accessible inside as well as outside the function. Now, let's discuss one of the topic where we will be modifying global inside function. Okay, so we will take this example itself, and here what we are doing is, initially here we have declared a variable x and has assigned its value as 50. Now we have created a function inside. Let's give this keyword called as global x. Okay, and again over here we are changing the value of x from 50 to 20. Now we will call this function, and at the last we will be printing the value of x. So let's see which value will get printed. Will it print 50, or will it print the newly assigned value of x, which is 20? So let's run this file. So see, it has printed value 20. So what does this mean? So using global keyword only when truly needed. Okay. So in this case, we have used this keyword called as global. So I would recommend use global keyword only when truly needed. And real world use case would be when we are dealing with configs or constants and environment variable. So there will be using keyword global. Okay, so this was all about the global and local variable. Now, moving to the further topics of this video, I want to discuss with you about modules and packages, right? So, in real projects, they have hundreds of functions, and we don't dump all code in one file. So, we organize using modules and packages. Now, what is a module? So if we go by definition, a Python file, as we have seen, all these are the Python file with extension as .py. So those Python file that contains functions, classes, or variables. So those are called as module. Okay. Now, uh, for example, we can consider these files itself, which are having an extension of .py. So those can be considered as module. Now, let me create another module, or basically another Python file. Okay, so I'll go here, I'll click on this new file or directory, and I'll give this module name as math underscore utility. And I'll give, so no need of giving .py, as it will directly provide that extension. So once I click on this Python file, we will see math underscore utility dot py getting created over here. Now inside this, let me create a function having name as add and provide two parameters, a comma b. Okay, then I'll be using a return statement which will be returning the value of a plus b. Again, I'll be creating another function which has this name called as multiply with two parameters, a and b again, and in the second line I am returning the result of a multiplied by b. Okay, now, so this is a module which I have created. Now let me use this particular module in a second file. So for that, let me create another file, and let me give this name as demo module. Okay, so in order to use the functions defined over here in math underscore utility module, what will be the first step which we need to do is we need to import that particular module using import keyword, and beside that we will be giving the name of that module, which is math dot underscore utility. Okay, now if I do a print with having inside this print, I'll be using this module name math underscore utility, and using dot operator I can call whatever functions is present in that particular module. So there are two functions which I have already created. One was add, the other was multiply. So let's call this add for now. Okay, and we will give the parameter values also. So this time let's give 10 comma 5. Okay, same way in the other line, let's try and print the results of multiply. So again we will put this module name, and with a dot operator module name, and with a dot operator we will call this multiply function, and parameter value let's give 3 comma 4. Okay, so if we run this file now, we will get the result of 10 plus 5, which is 15, and 3 into 4, which is 12. Okay, so see, this whole setup, it has solved the purpose of reusability, cleaner code, and professional development style, right? So coming back to the first question which I have asked, right? If we are working in a real project which has hundreds of functions, we don't dump all the code in one file. So for example, here we have created one such module which has add and multiply. Let's create another utility file which will have the functions of doing mod as well as division. So in this way, what will happen? Our code becomes much cleaner, and all these functions becomes reusable. Means these functions can be called in several other Python files by just providing this import statement, and then we are good to use all the functions which are present in the respective module. Okay, so this was all about module. Now if I talk about package, right? So first let's go by the definition of package. So a package is a folder that contains multiple modules. We have discussed that all these .py files are considered as module. So let me create a new Python package now. So clicking on file, then plus new file or directory. So here we will click for creating a Python package, and let's give this name as demo package. So if we place all of these files which we have created, or you can say modules, into this under this demo package, so this will be called as a package, and package is nothing but a folder that contains multiple modules. So if I copy this and paste it under this demo package, okay, so we have successfully imported a math utility module inside our demo package. Now while creating this demo package, we saw that this underscore init underscore dot py was created by default. So this will tell Python that this is basically a package. Okay, now let's further explain this package concept with a example. So here we have created a math underscore utility module, and in a separate file we have imported that module, and with that we were able to use all the functions present inside it. Now there's this another statement. Okay, let's me clean this up. From demo package, okay, dot math underscore utility import add. Okay, so what does that means? Now we have provided the package name, and with a dot operator, whatever modules is present inside this demo package, we have called that module. And now from this module we are importing a function called as add, right? Now once this function has been imported to this particular module, then we can do all the operations. So let's try and print using the function name add, and inside it let's give the parameter values as 1 and 2. So if we run this file now, it will return the output as 3. Now we can also import multiply function. So in order to print this output of multiply function, we have called this function name and provided the parameter name as 1 and 2 again. Now this time if we run, we got 1 plus 2 output as 3 and 1 into 2 output as 2. So this is how you can call all the functions present inside a module, which in turn is present inside a package using this particular statement. Okay, so does this look like a real world programming now, as we have seen how we can import modules and how we can import modules using package name and all the functions inside it? So you can see and have a look at it, which will give you a feel of a real world programming. Okay, so this was all about the modules and packages. So coming to the next topic of this video, which is called as exception handling. Now what are exceptions? So exceptions are nothing but consider them as an errors which occurs during runtime. Now why it is important to handle them? Because it prevents program from crashing. Second, it improves user experience. Third, it required in automation, APIs, Selenium script, and it also helps in debugging. Okay, so let me explain this with an example. So for that, let's create a new Python file. Let's give this name as exception handling. Okay, so in here, let me create a variable called as a equals to, and type as int, and inside input, here we will be writing statement enter number. Okay, and then space, and let's create another variable called as b. Same way here also we'll do the same thing, and at last let's print a divided by b. Okay, so what do you think what will happen over here? If we try and run this file, it says enter number. Okay, so let's put 0 over here, and if we run this file, we'll put 0 again, and then if we hit enter, the program gets crashed, right? What does that means 0 divisible by 0 is not possible. Okay, and it has given the error name as 0 division error, division by 0, right? So user makes mistake, but we must handle them. So in here, let's try and handle such kind of exceptions. Okay, so for that, we first method which we'll be using is try except. Okay, so we'll surround this block using try keyword, and in here we will be using except keyword, and here we will be printing something went wrong. Okay, so how it will help us? Okay, so obviously this whole setup will give you this particular error, but this doesn't seems good. Means we have to provide some logical reasoning that why this error has occurred. Okay, so for that we are using try and except block. Okay, now for that if we run this file, it has asked to enter a number, so let's give the value of a as 0 and provide the value of b also as 0. So see, instead of those red errors which we have seen earlier, this time it has printed something went wrong. So whatever error has been occurred inside this try block, we are catching under this except block by giving some meaningful name to that error or giving some meaningful statement that something went wrong. So it will help to analyze what went wrong and we can correct it out also. So inside try, we will be writing the risky code or the code which will be throwing any error, and inside this except we will be handling that failure. Okay. Now let's talk about handle a specific exception. Okay. So initially what we saw that let's say if we do not provide except over here or try over here, and when we run this file, what we saw was we were getting this particular error which says zero division error. Now in order to catch the specific exception, now which was here in this case it was zero division error, so we can write it in this way. So again, going back to that same arrangement of try and except, so we will write try over here, and then we will be printing a divided by b, and then we will be giving this except keyword, and here we are trying to capture the specific exception which was zero division error. Okay, so in case if this particular exception occurs, what it will do, it will print this statement cannot divide by 0. Okay, and also let's accept another thing which is called as value error. Okay, and here also let's print please enter only numbers. So we thought that this value error can also come. So we are catching that in another except block with the same name as value error. And then if this particular exception comes, it will print please enter only numbers. Okay. Let's run this file. So again, let's enter 0 and then 0. So zero division error has occurred and it has captured it, and it has printed the statement which says cannot divide by 0. Now if we again run this, okay, so let's put a instead numerical value. So it has encountered value error, and this time it has captured it and has printed please enter only numbers. Okay, so handling specific exceptions can be considered as a professional coding, right? Now there is this another concept in exception handling which is called as finally. So we have seen how a risky code can be captured inside try, and the specific exception can be captured with except. Now there's this another keyword called as finally. Okay, so let's take the same example, and here we will be write this keyword called as finally followed by colon, and inside finally let's print I will always run. So you'll get to know about it once we run this file. Let's provide value as 0. Again, for B also let's provide value as 0. And if we hit enter, see, it might have encountered 0 division error and it has printed cannot divide by 0. But you will see that what we have written inside this finally block, I will always run, this has also been printed out, right? So what does this means? So if we give any set of code inside this finally keyword, so finally runs whether error happens or not. Okay. So for example, let's say you are working with any kinds of closing files or DB connections or browser, etc. So you have done some coding, it has thrown you some error, but at last you want to end this entire code also. So for example, let's say if you are working with any kinds of DB connection and it has given you an error, so at the end of the code you want to close that DB connection. Or if you are launching a browser using Selenium, in between there's some error which occurred, you have handled it, but at the end you want to quit that browser also. So all those codes you can write inside this finally, so this will always execute, right? Whatever you run, sorry, whatever you print over here or whatever code you are putting under this finally, that will get executed no matter if you get any exceptions or not. Okay. So, what would be the real world use cases? So, in case of functions, if I talk about real world use cases for functions, which we have discussed at the beginning of this video, so it can be used for repeated business logic. It can also be used in Selenium helper functions and can also be used for API calls. And for global and local variables, use case would be for config values and state handling. Similarly, for modules and packages, the real world use cases would be project structures and reusable utilities. And coming to exception handling, so it can be used to prevent crashes, for Selenium failures, for API response errors, and for file handling. Now, your Python code is no longer a beginner level, and I must say this is a professional Python programming. So, today, we've learned how to write reusable functions, manage variables smartly, organize project using modules and packages, and handle real world problems using exception handling. So, these features transform Python from a learning language to a real world production language. So, with that, I'll conclude this video. And thanks for staying up till here. And if you like this video, please give a thumbs up and comment and share. Thank you so much. Hello and welcome again. So, the agenda for this video would be to understand what are classes and objects in Python. And in the second part of this video, we will see about what inheritance is all about in Python. Okay. So, till now, we have worked with functions and variables. But real world programming is not just about storing values, it is about representing real world things. Now, let me ask you a question. So, in our day to day life, what are the things which exist or we see around us? So, it could be a car, a phone, an ATM machine, a laptop, mobile, all of this, right? So, each of these things has two things, it has characteristics and Second is the behavior. So, speaking in terms of technicality, characteristics represents data and behavior represents action. Hence, in programming, we represent these using classes and object. Okay. So, a class is a blueprint or template to create objects. So, this is the basic and technical definition of a class. Now, if we talk about the definition of an object, so an object is a real instance of that class. So, if you have worked with any other programming languages which support object oriented programming, such as Java, so there also you might have heard about the concept of class and object. So, it's more or less the same over here as well in Python. So let me give you another example. Let's say if we talk about a real world example. So let's say there's this car design, right? So a car design can be of, let's say, Creta, Hyundai i10, or Maruti Brezza. So all of this will be fall under the category of car design. Now, let's say you own a car from Maruti Brezza. So, that actual car will represent as an object, and car design will be represented as class. Now, if we take another example, let's say mobile model. Let's talk about iPhone 17. So, that will be representing a class, right? And if you own any iPhone 17, then that will be an object which represents to iPhone 17 class, right? So class defines an object exists. Now, if I clear this out, let me first. If I say class, it defines what a student is. And if we talk about object, so that represent an actual student. So let's consider an example where there's a class which has n number of student. So consider a class of 10th grade, right? So what it will define? So it will define that the all the students which are studying here are of 10th grade. Now if we talk about object, so let's pick any one student from that 10th grade class. So that student will represent the object. Okay. So enough of this theory part. So let's move from theory to some hands-on coding. Then you will get some more understanding about it. Let me clear this out. Let's define a class called as student. Okay. And in here we'll say pass. So what pass is we already know. Okay. For a quick revision, we apply pass where we want to create any kind of placeholder. Okay. So let me make this C as small. Now it's all good. And here below pass, let me create an object called as obj. If I try and print this object, so let me run this file once. So see here it says main student object at the some value they have given. So let me explain this to you. uh, there's this class keyword involved. Okay. And the name of the class is student, and obj stands for object. So while running this file, did our file crashed, or this program got crashed? No, right? So meaning class is real now, right? Now let's add some attributes to this class. Okay. So initially we have given pass over here, so now let's add attributes. So first attribute would be, let's define a variable called as name.
and assign its value as Rahul. And let's define another variable called as age and give its value as, let's say, 21. Now what we will do, we will create an object. So uh, let's this be the object of the class obj, and now this time we will try and print using object name obj dot name. Okay, and in the second line, let's print the attribute value of age. So let's print age. Okay, so if you look at this particular section of code, right? So this name and age, these are called as the class attributes, and they are stored inside class, and they are accessible by the object. So here we have created an object, and using this object name along with a dot operator, we are able to access both these attributes, right? Now if I run this file, what it will do, it will simply print the value. Okay, let me create another student, say class student 2. Okay, and this time let's give the name as, let's give Pawan, and let's define the age attribute and give its value as 22. Okay, now for that, if or else let's give this attribute name as name1 and age1. So using this same object, we cannot call these name1 and name2. So see, if I put a dot operator, it will still shows age and name for the previous ones. Okay, so for that you have to create another object called as obj1, and let's give the class name as student2. And this time, if I use this name object name as obj1 along with a dot operator, we'll get all these attributes which are defined under this class called as student2. So let's take this as age1 over here. And now if we run this file, what will the output? So it has printed age1, which is 22, and here with the previous object name we are calling age, which has value 21, and it has printed the same. Okay, now coming to the next part, so let's talk about constructors and instance variable. Okay, now what is constructor? So in our previous videos we have seen this particular thing which says underscore init underscore followed by small brackets. So this is a special function that runs automatically when object is created. Okay, you will get to know more about it once we have this demo example. Okay, so let me clear this all out and let me create another class student, and let's create this function. Okay, and over here let's put this statement. I'll explain all this at the end once I write this whole code. Okay, okay. And over here, let's define another attribute called as age, and let's call that as well. Okay. Now let's create two objects. One is s1, and we'll call this class name and give the parameters as James, and so name would be James and age is, let's say, 25. Okay, and another object s2 with name as again class name, and this time let's give name as Jim and age 30. So if I do a print s1, we'll call this first object name dot, and put name over here. And secondly, again using the first object name, let's print age. Okay, and again let's do a print. Here we'll call the second object name and do the same thing. So before running this file, let me explain each and every step. So here's self. So what does this self mean? So self refers to current object, and each object stores its own data, right? So there will be a separate memory also allocated to it. And now we can create unlimited students, right? So as we have created two students over here with name James and Jim, and their ages are 25 and 30 respectively. So if I run this file, so see, it has printed about the name and ages of those two students. So if I ask you a question like which one is more flexible, hard coded variables or constructors, right? So we have worked with variables also, assigning their values or hard coding them. And now in this example, we are doing the same thing using constructor. So both these example, if we compare, then we can say that constructors are more flexible. Okay. Now let's go to the further section of this video, and talk about methods. Okay, so objects should not only store data, they should also perform actions, and that can be done using methods. So what will be the technical definition of method? So a method is a function inside a class. Let's explain this with another demo example. So let me clear up till here. Okay, and now we will use this self again to call name, and let's do that again for age. Okay, and let's create this function called as def, and function name as say underscore hello, which will have this self current object. And then we will do a print which will say hello plus self dot name. Okay, and in the next line, let's print my age. Then we'll put plus over here. Okay, here we are changing the uh, integer type to string. Okay, so that both the strings can concatenate. And now let's create an object called as s1, and here we'll call the class name, and put this name as, this time let's put Tim. Okay, and then we'll call this object name, and using this object name we'll call this function say hello. Okay, so let me clear these indentations errors. Okay, now here what we have done, we have created a method basically with name say hello, and this method belongs to this particular class. And to call this method, in order to execute it, we are using the object name, right? So here we have created the object for this class, and given the values as Tim for name and 25 for age. And at the end, we are calling this function using this object name. Okay. So if I run this file, so it has printed hello Tim and my age is 25, right? So let me ask you a question. So what do you think will print if the name changes, right? So let's print over here as Neha, and if I run this again, so this time it has printed hello Neha and my age is 25. So that's what we call as an interactive learning, right? So coming further to the next topic of this video, which is class versus instance variable. Okay, so I'll give you a quick explanation. Okay, so let me clear this out first. So let's say if a type is instance variable, then this belongs to a specific object, and the example use would be name, age, etc. Okay, now let's say if the type is class variable, so it will belong, or I can say like this, it belongs to means it is shared by all, and example would be college, school, team, etc. Okay, so uh, so basically instance variable that belongs to a specific object, an example would be name, age, right? And if I talk about class variable, so that will be shared by all, and example would be college, school, or team, right? So let me clear this out with a demo example. So let me again create a class named as student. Okay, and over here let's have this variable called as college and assign its value as ABC University, right?
College equals to ABC University, as this belongs to class, so this will be considered as a class variable. Okay.
Now again, let's have this function. This time let's keep only one variable, which is name. Okay, and let's call this name using the statement self dot name equals to name. So this will be the instance variable. I'll write it over here, and then let's create two objects. S1 is equals to student, and put the name over here as Rahul, and let's create another object for another student whose name will be, let's say, Priya. Okay, now it's the time to print them. So we'll use S1 object name to call name. Okay, and then we'll use again this S1 object to call college. In the second line, let's do the same thing using second object S2. We are calling name and college. Okay, so before that, let me run this file. So see, it has printed the name of first student as Rahul, who belongs to ABC University, and second student Priya, who again belongs to ABC University. Now, what if I change college for S1? Will it affect S2? So let's try and do that.
So here, let's do this print, and let's say before name change, and now Here, what we are doing, we are changing the college name of S1. So we will call this object name S1 dot, and we'll use this college attribute. And here we will say XYZ University. Okay. Now let's say if we print again after name change, okay, if we print these two values again, let's copy and paste it directly over here. Let's see what would be the output. So see, before name change, it was ABC University for both Rahul and Priya. Now after name change, Rahul University has been changed to XYZ University. However, Priya's university is still ABC University. So that was all about the class variable and instance variable. Now coming to our next section of this video, let's talk about what are inheritance in Python. Okay. So have you ever wondered why we don't build everything from scratch in programming? So just like in real life, children inherit features from parents. In Python too, classes can inherit properties and behaviors from other classes. And so this feature is called as inheritance. Now, if we go by the technical definition, inheritance allows a class to use the attributes and methods of another class without rewriting the code. Hence, it solves the purpose of code reusability. It helps in less duplication of code, and also it helps in easier maintenance, and at the end it totally contribute towards the professional programming. Now let me clear this out with an example, and before that let me tell you the syntax of it. So let's say if you create a class with a name parent, so if you want to inherit this class into a child class, so let's say you create another class with name as child. So if you want to inherit this parent class, so within the small brackets, you just need to provide the name of your parent class. So this is basically the syntax of inheritance. And just like a real life, a child gets properties of parent automatically. And so in case of inheritance, whatever functions or attributes parent class has, all those will get inherited by the child class. So let's begin with a demo example. For that, let me create a class with a class name as animal. Okay. And let's create a function also under this class having name as speak. So here we will print the statement called as animal makes a sound. Now let's create another class. So this will be acting as a child class. Let's name this as dog. And to inherit this particular function into this child class, we will provide the parent class name within this small brackets. Now let's have it this pass over here, as we don't need to write any code for this. We are just trying and implement this function into this child class. Okay. So for that, let's create a object called as d, and here we'll provide the class name of the child class. So this will be the child class object. Now using this child class object, we will be able to call the functions present in the parent class. So we'll just write t and followed by a dot operator. We'll use this function which is defined in the parent class, right? Now if I run this file, see, it has printed animal make sound. So this explains that the child class dog haven't had this function speak defined inside it, and still it can use it. So this is called as inheritance. Now, did we wrote the code twice? No, right? So this solves the purpose of code reusability. Now, this was one such example. Now, in the same example, let's add a function to this child class as well. So let's define a function with a name as bark. Okay. And in here, we'll do a print statement again. And inside it, let's write this dog makes a bark. Okay. Now again, we'll create this child class object. So we will call this parent class function with this child class object, and even the function which is written inside this child class can also be called using this child class object. Okay. So if I run this, now I have this two statement getting printed, which is animal makes a sound and dog makes a bark. Okay. So now child class can do everything parent can, plus its own extra features. So whatever functions parent class has, along with that, whatever functions child class have, so this child class is capable of doing both of this together. Okay. Okay, now let's discuss about this concept called as method overriding. So sometimes what happens, child doesn't likes parent behavior and says I'll do it my way. So this is called as overriding. Okay. So let's explain this as well with an example. Now, in our previous example, we have defined this function called as speak inside the parent class animal, and there was this different function called as bark inside this child class element. What if I create this same parent class function over here as well and name it as speak? Okay. So in here, we have the function having the same name for both child as well as parent class, right? Now, what will happen inside this parent class? We have defined this print statement which says animal makes a sound, but inside this child class function, which is speak again, we have printed this statement: dog makes a bark. Now, what would be the output? So let's try and run. Now, this time only one statement got printed, which is dog makes a bark. Because what happened, whatever was initially performed under this speak function for the parent class, we have changed its uh, implementation inside the child class. Means we have changed the print statement basically, and this time it has printed only what is there inside the child class. So this the whole concept is called as a method overriding. So child replaces parent method, and Python always prefers child version. Okay. Now there's this another concept of multi-level and multiple inheritance. Okay. So let me explain this with an example. So we have seen a parent, then a child. Okay. So whatever properties parent have, automatically child inherit those properties. Now let's say child has another child of his own, which will be the grandchild of the parent. So now whatever property this parent is having and whatever property this child is having, so all of these property will be inherited by the grandchild. Okay. So let's discuss this with our demo example. This time we are creating a class. Let's name it as grandfather, so it will be more clear to relate. Okay. And in here we are defining a function called as property. Okay, and inside property, let's do a print saying grandfather's property. Now let's create another class called as father, and here we are trying to inherit grandfather class. Okay, so we'll put this parent class name over here, and let's create another function. This time let's name it as car. Okay, yeah, so here let's print father's car. Okay, now let's create another class which is, let's say, called as son, and in here let's inherit this father class over here. Inside, let's define another function. This time say it's bike, and print son's bike. Okay, now for that, let's create an object of this son class with s as the object name, and here im- let's try and call this car function which is defined under this father's class, and this bike function which is there inside this son class itself, and let's call the function which is present under the grandfather class, which is property. So if I run this file, what I'll see, all the three statements getting printed over here, which is father's car, son's bike. Okay, this, let me correct the spelling. This is grandfather's property. So see, all the three statements has been printed. So that means properties pass through generations, just like in real life. Here in programming also, the properties pass through generations. So with this son class, we were able to get or inherit whatever functions was present in the grandfather class as well as father class. So this is called as multi-level inheritance. Okay. Now there's this another concept of multiple inheritance. Okay, so which means that here child will inherit from two parents. Okay, so let's get this cleared with an example. Now this time let's create a class called as father. Okay, and here let's define a function called as car, and let's do a print which says car from father. Again, let's create another class. This time let's say its name is mother, and here we are defining a function called as house, and here let's print house from mother. Okay, and now is the time to create son class. Here we will be doing, what we'll be doing here, we are inheriting from both father and mother class, so you can put the respective name. So let's do it like this. We'll put here father as well as mother. Okay, now here let's give nothing, simple pass. Now let's create an object of son class with an object name as s, and let's try and call one function from father class, the other function from mother class. So if I try running this file, so see, both the statements got printed. So the son got car from father and house from mother. So this is called as multiple inheritance. Means a son or a child class can inherit from two parents also. Okay. And also Python supports multiple inheritance, and it's a powerful concept, but you must use it wisely. More we'll get once we start working with some automations. Okay. Now there's this another concept of super. So what happens sometimes child wants its own version plus parents behavior. So for that we use super. Let's explain this also with an example. Now this time let's create a class called as animal, and again create a function called as speak and print animal speak. Okay, again we will be creating another class called as cat. Now this will inherit this parent class animal. Okay, and let's create another function called as speak, having the same name of the top present in the parent class. Now here we'll use super, which is written like this, and using super along with dot operator we are calling the speak over here from the parent class. And then let's do a print cat speaks. Okay, this we are going to print under this function. Now in order to call this function speak, we need to create the child class object. So let's do that. C is equals to cat. Okay, so we have created this child class object having name as C, and now using this C and a dot operator we are calling this function speak. Okay, so now let's run this file and see what happens. Okay, so here we have the output as animal speaks, which is coming, which has written under the speak function for the parent class, and we have this statement called as cat speaks, which is coming from here. Now, if you look closely under this child class, we have created this function called as speak, right? And after that, using super, we are calling this function from the parent class. Okay, so, and after that, we are printing cat speaks. So, what happens? Super calls parent methods before and after the child logic. So, here, super is calling the parent method speak, and it is printing whatever is written under this print statement, which is animal speaks. And after that, this particular line is getting printed. So this is the whole purpose of using super in order to call the parent methods before or after the child logic. So with that, we have covered the agenda for this video, which was the classes and objects in Python. And also we have seen how inheritance works. So we will conclude this video now, and I would like to add this point as well. Like inheritance allow us to reuse code, reduce duplication, and build professional scalable application. Okay.